the next application of divide and conquer. What is the name? Counting number of inversions. Next application of divide and conquer is going to be counting number of inversions, right? To this one, input is going to be an array of n integers. Output is going to be count number of inversions. To this problem, this is the input and this is the output. Right? Fine, that's okay. Now, some people are asking, sir, what is the meaning of inversion? See, inversion definition. What is the meaning of inversion? Right? I written also. See, what is the meaning of inversion? See everyone. For two indexes I and j, if I less than j and a is greater than aj, then these two are inversions. Who are the inversion? ai and aj is inversions. For two indexes I and j, if I less than j, means if you see the indexes, comparing I, j bigger, but if you see the values, a is bigger than aj, then these two are said to be inversions. Right? Please be careful. Inversion definition is this one. Like that, how many people are there? Those many inversions. Right? It is one inversion. Right? Then these two are said to be inversion to each other. So one inversion we computed. Like that in the given array, how many inversions are there? We have to find out. I am repeating once again to this problem. Input is one array. Output is going to be count number of inversions. The next question is going to be, what is the meaning of inversion? Right? Next question is going to be, what is the meaning of inversion? Right? This is the meaning of inversion. For two indexes I and j, if I less than j and a is greater than aj, then these two are said to be inversions. Please be comfortable with the input and output. What is the inversion definition also I explained to you. Right? Fine. Now, some students are asking, sir, how to find out and all. With the help of a numerical example, I will explain. Afterwards, we will go to the algorithm and all the things. Please be careful. Please be careful. How to count number of inversions with the help of a numerical example. Now, I am going to explain. Let me explain now. One example. Please be careful. One example. Array A. Some elements I will take. Let me take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements are there. Otherwise, let's go for right 7 elements. Right, 1, 2, 3, 4, 5, 6, 7. Right, let's go for 7 elements. If you take more elements, big diagram will come. That is the reason 7 is enough. Let me take the values also. Let me take values. 50. See the values. 50. 50. 70. 13. 9. 85. 21. 16. Some numbers required I written. 50, 70, 13, 9, 85, 21, 16. Right? This is the array. In this array, how many inversions are there? We have to find out. Inversion definition also you know. Right? If I less than j, but a is greater than aj, then it is called as inversion. Right? In this particular array, how many inversions are there? I have to count. Let me count here. How many inversions are there? Please help me. For the index 1, who are the inversion? So, if you see this array, indexes are increasing, you know. But values are decreasing or not, I don't know. Let's count here. How to find out number of inversions? I'm starting. How to count number of inversions? I'm explaining. See this one. Here index 1. Indexes are increasing, you know very well. Right? What about values? Let's check. So, this person, first person is asking to me who are inversions. So, what is the answer? He will ask next person. Right? So, are you inversion or not? See, value, right? Index increasing, value also increasing. It is not inversion. He will ask this also. Right? Index is increasing, value decreasing. I think it is inversion. Right? Can you say for the 50 who are the inversion? 13 is inversion. Next. 9 also inversion. Next. 85 no. 21 also inversion. Next. 16 also inversion. So, for the 50 these many inversions are there. Count. 50, 70 not inversion, 85 not inversion, right? I think 2 people not, remaining all. Who are those? 13, 9, 21, 16. 4 inversions in the similar way. What about 70? Check. 70 inversions, right? No need to go back because already 50 asking 70, 70 asking 50, both are okay, right? Just ask the other people. So, 70 will ask next people. So, is it inversion? Yes. Next one? Yes. Next one? No. I think remaining 2 are inversions. 21, 16. These are inversions. Right, next one, that is also 70 also okay. Can you help me now? For the 13, who are the inversion? No need to go back, go further. 13, who are the inversion? 9 is inversion. That's it. Next one, can you help me now? For the 9, who is the inversion? For the 9, who is the inversion? No one. Right, 9 no one is inversion. Next one, what about 85? 85, who are the inversions? 21 and 16. Right, next one, 21, who are the inversion? I think 16. For the 16, who is inversion? Right, no one. So this is the story. Can you help me? For the 50, how many? 4. For the 70, 4. For this one, 1. For this one, 2. For this one, 1. Add all of them, 4, 4, 8, plus 1, right, 2. Total how many? 8 plus 9, 10, I think 10 and 2, 12 inversions total. Total 12 inversions. Please check. Right? For the 9, no inversion. For the 16 also no inversion. Remaining if you count these two, 4, plus 1, 10, plus 2, 12. 12 inversions are there. To this array, right, to this array, number of inversions are 12. And one more thing I want to ask you. Please see this one. This is the way how to count number of inversions in the given array. But one thing, am I apply divide and conquer or not? No. Simply I asked, right? I think something like brute force method. Brute force method, another name, linear search. Covering all the, everyone you will ask, that is called brute force method, which is also almost like linear search only, right? Can you help me know what the answer? 1 will ask everyone, linear search. 2 will ask everyone, linear search. I think one person is asking all, like that n times going on. So what is the time complexity of this algorithm? Order of n square. Because 1 is asking everyone, 2 is asking everyone, 3 is asking everyone. So I think n times n, right, n square, right, n square. To this algorithm, time complexity order of n square every case, right. This is not divide and conquer. Within divide and, right, using divide and conquer, how to finding number of inversion, within few minutes I will explain, don't worry. Just I want to give introduction, right, what is the meaning of inversion, how to count. Yes, I counted. Right, I just applied the brute force method or linear search. N times linear search I done, n square. So every case to this algorithm time complexity n square. But how to solve this problem using divide and conquer, I will explain now. How to solve this problem using divide and conquer, I will explain. Let me start. Right, that is the array. Array also already there. So let me start this one. Using divide and conquer, how to solve this problem. And one more. Some people are asking, using divide and conquer means first step is going to be when the problem is small. Right? Only one element is there. Right? Problem small. Only one element is there. How many inversions? 0. 2 also you can say problem small. Whatever way you want, everything is okay. Everything okay. Assume that one element is a small problem. Then number of inversions are 0. Otherwise problem is a big problem, divide. Like exactly merge sort, Merge sort, whatever way you divide, same way divide. In the merge sort, one element is there, small problem. Here also small problem. Everything like merge sort only. Please be careful. Right? I am starting. See this one, I am starting. This is the array already there. See the answer. See everyone. Array A. Everyone listen this one. Nice algorithm is coming, which you know very well. It is the merge sort only. See this one. Array A which contain 1 to 7 elements. You want to count number of inversions. Array A which contain 1 to 7. In that you want to find out number of inversions. How many we will get here? We will get finally we will get here. So to do this one, to do the number of inversions in this particular problem, right? Because it is a big problem. Divide like merge sort. Divide. What is the answer? 1 plus 7. 8 by 2. 4. So array A which contain 1 to 4. Count number of inversions on the left. Array A which contain 4 plus 1, 5 to 7, count number of inversions on the right. If you want number of inversions at this place, right, both the left and right number of inversions you count, you add them, you may get this answer. Right, just to take the here how many came, here how many came, add them, mostly you will get this answer. In the similar way, what about this one? Same. What is the answer? Array A which contain 1 to, I think 5 by 2, 2.5 means 2. 1 to 2, how many inversions are there? Count. Next one, array A which contain 3 to 4, number of inversions count. Same thing here also, 5, 6, 7. Array A which contain 5 to 5 plus 7, 12 by 2, 6. Array A which contain 5 to 6, number of inversions count. Array A which contains 7 to 7, count number of inversions. Next one, similar way, array A which contain 1 to 2. What is the answer? A 1 comma 1, number of inversions count. A2 comma 2 number of inversions count. A3 comma 3 number of inversions count. A4 comma 4 number of inversions count. Only one element means small problem. Same thing here also. A5 comma 6. A5 comma 5 number of inversions count. A6 comma 6 number of inversions count. Right, like this. So this is the way. Just divide until small problem. Exactly like MEDSAT, I am not done anything. Right? MEDSAT algorithm, everything you know. Right? Just divide. Fine. Can you see how many level tree will come? Because of always you are dividing by 2 log n. Log n level tree will come. That is also okay. Right? Let's start. How many inversions are there? We have to count. So you know very well. Function calling order, everything you know. Right? Function calling order, everything you know. Let me try that also. See this one. I am starting. Right? Can you help me now? To do this one, these two required. Means first it is required. It is required. It is required. I think here. You know very well. A11. Can you go to the A11? Go to the A11. Can you help me now? A11 means first element. A11 means first element. See this one. A11 means first element. A11 means first element. See this one. Only one element is there. Number of inversions how many? 0. A11 means small problem because of only one element. Number of inversions 0. That is fine. But what is the element? 50. Right? Number of inversions 0. Right? That is fine. But element you have to take. You have to take element. If you don't take element, further how will you compare? As of now, number of inversions 0. I am okay. But further how will you compare? Further, right? You have to take the element also. So this problem is solved. Number of inversions 0 came. Right? But element is 50. In the similar way, A22 go there. What is the A22? 70. Right? So number of inversions as of now because of only one element 0. Right? Element is 70. So this is also completed. This is also completed. Right? Like this. Right? This is also completed. This is also completed. Fine. Number of inversions as of now left 0, right 0. Right? Left 0, right 0. Now see the interesting answer from now onwards. Careful. What I am doing now? Sub problems are solved. Now I am doing combining. Means I am doing merging. Please be careful. I am doing merging. You know merge algorithm very well. Left one element, right one element. When you do merging, how many will come? 2 elements in the sorted order will come. Please be careful. Exactly merging only. Divide. So I am repeating again and again. This problem is equal to merge sort only. This problem, merge sort, both are same. Minute change is there. One small line. I will say within few minutes. So let's see, divide is over. Now conquer is completed for this. Now I am doing combine. Means I am doing merge algorithm. Can you say left how many people? 1. Right how many people? 1. If you merge them, how many will come? 2 in sorted order. Please be careful. 2 in sorted order they will come. Right? Let's see this one. Can you help me now? When you do merge algorithm, all elements will come in sorted order. I am okay with that. See this one. Left how many inversions? 0. Right how many inversions? 0. See everyone now. 0 plus 0. This one add 0. 0 plus 0. When you are doing merge algorithm, right, you have to count the total number of inversions. Left how many plus right how many. Just do that first. Yes, I done. Left how many plus right how many. Just add both of them. You keep in the parent. That is also okay. But see, few more will come. Right. Left how many there. You have to count. That is okay. Right how many there. That also you will count. It's okay. But when you do merge, there some more inversions will come. Some people are asking, sir, how? Let's see. See everyone, listen. When you are combining, assume that 70 this side, 50 this side. It is an inversion. Everyone, who is the left person? 50. Who is the right person? 70. What is the meaning of left person? First person. Who is the meaning of right person? Second person. So comparing the left person and right person index is less. Left person value also less. So there is no problem. Sometimes 70 this side, 50 this side. This is called inversion. So left how many inversions are there? Add. Right how many inversions are there? Add. That is okay. But when you are merging, there may be some more inversions will come. Can you help me now? So let's see the merge algorithm. I am doing merge algorithm. 50, 70, which is smaller? 50. See this one. 50, 70, which is smaller? 50. Smaller one you have to take. I am taken. But one thing is true. 50, 70, 50 is smaller. But it came from which side? Left side. Indication that index is less, value also less. There is no problem. It is not a inversion. I compare the first element of both, smaller one I will take, that's okay. But smaller one is came from left side or right side? Left side means what? Index less, value also less. It is not a inversion. Just do merge algorithm. That time just count number of inversions again. So left plus, left how many plus, right how many plus, merging time some more will come, right? Now it is not inversion here because 50, 70, 50 smaller, it came from left side because it is there. Left side means what? Index also less, value also less. There is no problem. Next one, whatever elements are left out, copy. When you say merge algorithm, all should come, right? Like that. So number of inversions how many here? Left 0, right 0, right? While combining also no inversion is came. Until now 0. Until now number of inversions are 0 in this area. Those people who are troubling little bit also, let me do here also. Can you say what is the A33? See the array and top. What is the A33? 13, number of inversion 0. What is the A44? 9, number of inversion 0. Please be careful. Now I am merging now. Carefully listen. Now I am merging now. When you merge, left 0, right also 0. Now let me do merge algorithm. Can you help me now? 13 and 9. Who is smaller? 9. 13 and 9. Whoever is smaller, he will come. That's okay. 13 and 9. 9 smaller. He came first. It's okay. But one thing. Small came from left side or right side? Right side. What is the meaning? Right side index is more, but value less. It is called inversion. When you say inversion, plus 1 you do. 13 and 9, 9 smaller. So take the smaller one to the right. When you combine, when you do merge algorithm, smaller one you have to take. Yes, I took already. But one thing, small came from left side or right side? Right side. Right side index more, but value less. So that is the reason it is called inversion. Right. Next one, whatever elements are there left out, just take as it is. Can you say how many inversions this side? 1. Right, like this. This will keep on continue. But one point is still pending, right? I will cover that one. It is a serious, it is a very, very important point. That is a major part of this entire story, right? Now it may come within few minutes, please you take care. It may come within few minutes, right? Fine. So can you help me once more? Because of you are little bit comfortable, right? I think it is the correct time to say that logic also. I am saying that logic. Listen now. The major point, I think major point I can say, until now I didn't said major point, right? I will say that major point now, so that you don't confuse further. It's the correct time. Previously I want to say you may confuse, right? Now it is the correct time. Let me say this. So see this one. This is available, this is available. Both are available. Now I have to merge again. When you say merge, what is the answer? Left plus right. While merging, some more will come, right? Let's see that point now. I am saying now that point. Let me check. See everyone, interesting one. See everyone. Can you help me now? If you want to do merge algorithm, both should be sorted or not? Yes, see, this is sorted, this is also sorted. If you want to do merge algorithm, left should be sorted, right should be sorted, then only you can merge, right? Let me take here. Carefully listen. Interesting point, carefully listen. 50, 60, 70, 80. 50, 60, 70, 80. Right? So, can you help me? Is it sorted? Yes. Left half is sorted. See everyone. Next one. If you want to do merge algorithm, two sorted subarrays required. Fine. Left one is sorted. See the next one. See the next one now. 5, 19, 55, 60, 55. Isn't there 55? Next one is going to be 76. Right? Like that, some elements. See the elements here. 5, 19, 55, 76. Right? So can you help me? Is the left half is sorted? Yes. Is right half is sorted? Yes. Now I am doing merging. Please see the answer. Interesting one. Left one, right one, both are sorted. I am doing merging now. You know merging very well. But while doing merging, how to count number of inversions? I am explaining now. This is the major line I am explaining. See once. Can you help me now? Left hand side, how many elements are there? 4. Right hand side, how many elements are there? 4. As of now, left 4 elements are there. Not left 4 inversions. Left 4 elements are there. Right also 4 elements are there. Now I am doing merging now. See the answer? Now I am doing merging. Everyone listen. I am doing merging now. When you are doing merging, right, you know very well. Whom you compare? Both the first elements compare. See the interesting one. Both the first elements compare. Compare now. Left 4 elements there, right 4 elements are there. It's okay. Right? When you are doing merging, first elements you will compare. Compare now. 50 and 5, compare. Can you help me if you compare 50 and 5, right? Who is smaller? 5. Merge algorithm you know very well. 5 is smaller. Compare both the first elements, right? 5 is smaller, take. But one thing is true. 5 is smaller, you are taken, it's okay. 5 is smaller, you are taken, it's okay. But one thing, that small is came from left side or right side? Right side. right? Small is came from right side. What is the meaning of right side? Indexes are more. So comparing left index, right index is more, but value less. So this is called inversion. Small that came from right side, indication that right index is more, value less. So this is called as inversion. Comparing, see, first element is normally smaller. Comparing with this small element, if it is smaller, definitely comparing all people also is smaller, indication that whenever one inversion will come, please be careful. While merging, whenever 5 is a smallest one I took, but it is a inversion. Try to remember, whenever inversion is came, whenever merging is going on, if inversion is came, then don't take inversion as 1, right? If it is a inversion, it is inversion to all people also, these all people also. Then number of inversions are, please be careful, 4 plus. Why 4? Left hand side, how many elements are there? Those many inversions will come. At a time, all will come. See this one. For the first one itself, 5 is a inversion. For the first one itself, 5 is a inversion. For all these people, 5 is a inversion. Indication that whenever inversion will come, left hand side, how many elements are there? Those many inversions at a time will come. Now those people who didn't catch this point, right? They can see once again. So I think 5 is a inversion. Then at that time, 1 will not come inversion, 4 will come. After inversions are over, now cancel it. If anyone is struggling, again check. Can help you now. 50, 19 compare. Who is smaller? 19. Is it inversion? Yes. See this one. Compare. See, first element itself, if it is a inversion, means comparing first element itself, if at all he is a smaller, comparing all these people also he is smaller. Indication that, right? Whenever it is a inversion, again, left hand side, how many elements are there? Add those many. Right? So this also completed. Those people who are still troubling, you can see now again. Can you help me now? 50, some people are asking, sir, why this is not moving? They are not small. Small people only will move, you know very well. Whenever merging is going on, small only move. But you have to count the number of inversions also, right? Next one, again start. Can you help now? 50, 55, right? Who is smaller? 50. 50, 55, who is smaller? 50. But one thing is true. 50 smaller, it's okay. Can you help me now? 50 smaller came from which side? Left side, what is the meaning? Index also small, value also small. There is no problem, there is no inversion. Now, it is not inversion, then don't count anything. From the left side only small came. Indexes are small, value also small. Where is the problem? Right? But from the right hand side small came, then it is an inversion. But whenever inversion is coming, it don't come by 1. Left hand side, how many elements are there? That point of time, those many will come. Right? Let's start again. Can you help me now? 60, 55. Who is the smaller? 55. 60, 55, 55 smaller, but small is came from left side or right side? Right side. Means it is a inversion. Whenever it is a inversion, see this one. Comparing first element itself, if he is smaller, comparing other people also he is smaller. So what is the answer? 3 inversion. See, as of now 3 elements are there, not 4. Because of 1 you cancel, it became 3 now. 3 inversions will come. Right? Plus 3. Next, 55 is cancelled. Come to the next one now. 60, 76. Who is smaller? 60. But everyone now. Small came from left side, no problem. Now number of elements becomes 2. Next one. 70, 76. Smaller, 70. But small came from left side. It is not inversion. So 1 element there. Next one. 80, 76. 76. Small came from right side. It is a inversion. Whenever it is a inversion, right? Don't count number of inversion as 1. Count how many elements are there on the left hand side. How many there? 1 there. Right? Plus 1. Next one, because of I think one group, all are over. I think no inversion will come further. Whatever elements are left out, store there. Right? Now if you want, you can check now. Can you see how many inversions? 4 plus 4, 8 plus 3, 11 plus 1, 12, something like that. This is the way. Whenever merging is going on, if at all one inversion will come, if at all it is an inversion, don't count as 1. Left hand side, how many elements are there? Count those many. Some people are asking me, how it is possible at a time many will come? That is the advantage, right? If you sort, see this one, you sorted. Some people are asking, sir, why you sorted? In one of the class, one student asked me, right? In this problem, your goal is not sorting, your goal is counting number of inversions. Then still why you are sorting? Right? Try to remember this one. If I don't sort, right? To find out 4 inversions, 4 comparisons required. Because of I sorted, 4 inversions are coming. right? One comparison only. See this one. I compared these two. I compared first element of each 4 came. I compared second element here, first element here, again 4 came. With one comparison, many inversions are coming. Why? Already array is sorted. Left half is sorted, right half is sorted. Because of unsorted array you are doing, right? Some extra advantage is coming. Can you help me one small line? What is the time complexity without sorting and all? If you do blindly, see n square. See this one, why n square? In this particular algorithm, for this one, if I want to know how many inversions are there, everyone I have to ask. But here 4 inversions came at a time. One comparison I done, but 4 inversions came. One more comparison I done, 4 more inversions came. One more comparison I done, 4 more. What is the meaning? With less comparison, more inversions are coming. That is the advantage, because the array is already proper order. If the array already proper order, right, definitely number of inversions will come easily. But one thing, you have to, whatever work is over already, you have to keep in proper order. Means sorted order you have to keep. I am thinking you got little bit idea. Let's do this story on this diagram. Right? With this, almost everything is fine. Let's check here. Are you comfortable or not? Let me check. Those people who are thinking that, sir, I am not comfortable and all, see, big diagram is there. On the entire diagram, I will explain this logic only. Whatever I done, I will explain that logic only. Let me start. See this one. Let me start. Left how many elements? 2. Right how many elements? 2. That's okay. Can say left inversions already how many? 0. Right inversions already how many? 1. 0 plus 1 before going to merge. Already left and right how many inversions are there? Count first. That's okay. Now see from now onwards plus. Right? Merging will start. Start now. Can you help me now? Left how many elements? 2. Right how many elements? 2. Now start the merging now. 59, which is a smaller 9. Because of 9 is smaller, I took here, it's okay. But that small is come from right side. So it is an inversion. Whenever inversion is came, left how many elements are there? Those many inversions plus 2. Then cancel. In the similar way, 50, 13, smaller 13. But one thing, again it is an inversion. Left hand side how many people there? 2. Right? Plus 2 you add. Then cancel this also. Because the one group is over. Remaining group, right? Copy as it is. 50, 70. So until now, these many inversions from left side. Come to the right side, same story. See the answer, 0, 0. Can you say what is the fifth element? Can you say what is the fifth element? 85. What is the sixth element? 21. Now see the answer. Left 0 inversions, right 0 inversions. When you combine, what is the answer? 0 plus 0, it's okay. Plus, can you help me now? 85, 21, smaller, 21. But it is an inversion. Then left how many elements are there? 1 plus 1. Next one, further one group is over, remaining group copy as it is. In the similar way, what is the A7, 7, 7th element, what is the answer? 0 inversion, 16. Now start. Left 2 elements, right 1 element. Left how many inversions already? 1. Right how many inversions already? 0. Now start the merge algorithm. Can you help me now? 21, 16, smaller, 16. Right? But because of it is the inversion, left how many people? 2 plus 2 you do. 16 is cancelled. Next one, further no elements in one group. Remaining elements copy as it is. 21, 85. So until now this is the current status. Can you help me now? Until now how many inversions? For these 2 I added, it's okay. Can you say until now how many inversions from this side? 3. Right? Now see the answer. So from this side how many inversions? 1 plus 2 plus 2. What is the answer? 5. Left 5, right 3. Let me hear. Major thing is going on. Please check. Major thing, the major merge operation is going on. Please carefully listen now. Can I say left how many inversions? 5. Right how many inversions? 3. Let me write now. 5 plus 3. Plus. Now start. Can you help me? Now merge algorithm is going on. 9, 16, smaller, 9. But it is not inversion, leave it. 13 and 16. 13 smaller. It is not inversion because small is coming from left side. Next. 50 and 16, smaller, 16. But it is an inversion. Left how many? 2 plus 2. Next, 70 and 16, smaller. So, who is the previous inversion? Who is the previous inversion? Let me check here. So, can you help me? 50, 16, who is smaller? 16, that's okay. But inversions how many? 2. I added already, that's okay. So, 16 deleted. Next, see the next story. 50, 21, smaller, 21. Is it inversion? Is it inversion? Yes, why? From left hand side coming, 2. Next, 50, 85, smaller, 50. Right? It is not inversion. Next one, 70, 85, smaller, 70. It is not inversion. Remaining one, copy as it is. Remaining one copy as it is, right? I think all elements came sorted and it's okay. My goal is not sorted, but still I am doing. Why? My goal is not sorted, but still I am sorting. What is the reason? If you sort, right, counting number of inversions will take less time. Counting number of inversions will take less time. If you don't do sorting and all, right, it will take n square. If you do sorting, right, see this one, if you do sorting in further when you are going, it will become very easy. Can you count how many inversions came finally? 5 plus 3, 8, 8 plus 2, 11, 11 plus 2. See this one, I am repeating once again, 5 plus 3, 8, 8 plus 2, 10. Right, see this one, 5 plus 3, 8, 8 plus 2, 10, 10 plus 2, 12, 12 inversions total 12. If you want, you can check here also 12 inversions. Right, this is without divide and conquer, this is with divide and conquer. The only thing is, right, so while going back, right, sort, keep in proper order so that in top level work becomes less. Right, some people are asking, sir, if you do sorting and all, it will take some time, maybe n log n time sorting. Right, sorting may be n log n, but that is n square. That is a n square. Please be careful. Can you help? This problem merge sort. What is the difference? In the merge sort also you will divide. Next, in the merge sort also you will do merge algorithm. But whenever merge algorithm is going on, right, in the merge sort algorithm, you don't count inversions. Here you will count. This is the only difference. Right? So the major difference is this only. Whenever see one, same merging I done, same merging, right? Whenever merging is going on, whatever answer is coming, previously see one, in merge sort algorithm, whenever merging is going on, this answer only will come, this answer only. Now one more variable also increasing, this. This is the inversion story. In the merge sort, this story not there, right? But in this one, right? Same merging will be there, plus this story also, incrementing some value. Other than this, nothing there. Right, both will be similar, right? Please be careful. Merge sort and this one same. The only thing is whenever merge algorithm is going on, right, please maintain one variable to count the number of inversions. Whenever inversion is coming, whenever merging is going on, inversions are coming. Will you take one inversion or two inversions or number of elements on the left side? Number of inversion on the left side. Not 1, not 2, not 3. Left hand side, how many elements are there? That point of time, those many inversions I will take. Right? Fine. I am thinking you are a little bit fine now. Right? See, to get the more clarity, right? Just let me write one small story also. Let's see. See, this is merge algorithm. Whatever a merge algorithm you know, same merge algorithm. Right? This is the merge algorithm. If you want, I can make large also. This is the merge algorithm. Okay. See this one. Whenever merge algorithm is going on, please listen. You know this merge algorithm very well. See this one. M is equal to 1, some variable. See this one. M is equal to 1, K is equal to mid plus 1. M is equal to 1, just assume M is equal to 1, K is equal to mid plus 1. Now see the answer, merge algorithm. See this one, merge algorithm. Merge algorithm input is going to be two sorted subarrays. Can you say what is the first half? I to mid. What is second half? Mid plus 1 to j. You know this very well. Merge algorithm is going on. Input is going to be I comma mid is first half. Right? Mid plus 1 to j is k means mid plus 1. Mid plus 1 to j is second half. Now see this one. Until first half not over. See this one. I is first element position. Mid is right in the first group. I is first element position. Mid is going to be last element position in the first group. Second group. K is going to be first element position. J is going to be last element position. Now see the answer. I less than or equal to mid. What is the meaning? First group not over. K less than or equal to j. What is the meaning? Second group not over. You know merge algorithm very well. Same merge algorithm I am doing. I less than or equal to mid means first group not over. K less than or equal to j means second group not over. Means both the groups are not over. Means something is left in both the groups. Because see this one, this group also not over, some elements there. This group also not over, some elements are there. Then what is the merge algorithm? Both the first elements compare. What is the first element in the first group? AI. What is the first element in the second group? AK. AI and AK both compare. When you compare both the people, see, if AI is less than AK, what is the meaning? Who is smaller? AI is less than AK, then who is smaller? I think AI is smaller. Whoever is smaller, store that person in the B array. You know very well, merge algorithm is outplace merge algorithm. Whenever merging is going on, you will take another array. In that array, you will store your element. Right? See this one. AI and AI is less than AK, indication that AI is smaller, so smaller one will store in B. Because of you stored, that element cannot be taken further, so I plus plus. Whom you kept, right? This one. Which element you kept? AI. So I plus plus. In which place you kept? Mth place. M is initially 1. So like that it is going on. Whoever smaller, keep that one in the B. Whoever smaller, keep that one in the B. Compare AI and AK. Right? So if AI is less, then keep AI. Otherwise keep AK. Whoever you kept, then you have to do that one plus plus. This also same story. K plus plus. Right? Like that it is going on. So when if condition true, what is the meaning? AI less, then keep that one in the B. Suppose if condition fail, AK less, then keep AK in the B. Like that merge algorithm is going on. Now let me ask you one small line. When this loop will fail, any one over, first half is over, then second group, see this one, copy all remaining elements to B. Copy means move all elements to B array. Right? Like that it is going. This merge algorithm you know very well. Input, 2 sorted subarrays, first group I to mid, second group K to J. What is the K? Mid plus 1. Now, first group is not over, second group is not over, then compare. If AI less than AK, AI is smaller, store into B. Otherwise, AK smaller, store into B. Suppose this loop is somewhere stopped, what is the meaning? One group is completed. Right? Another group remaining elements, copy to B array. Right? Like that it is going on. And one more, whenever this merge algorithm is going on, inside you are using B array, one more array. So it is going to be outplace merge algorithm. That is also okay. Now listen, interesting one. Now listen. See everyone now. So this is the subarray which is sorted. This is the subarray which is sorted. You want to merge these two. This is the subarray which is sorted, this is the subarray which is sorted. See, both are individually sorted, you want to merge them. Can you help me now? Right, this is sorted, this is completed. This is also completed, sorted, this is sorted, fine. I want to merge it, but listen. Before starting, carefully listen, before starting. Number of, see this one, number of inversions before starting. Before starting merging, see this one, I am starting merging, so after merging I will get some answer here, it's okay. Right? Before starting merging, number of inversions, how many? Number of inversions is equal to before starting. Left how many inversions already? Isn't that left is some X inversions? Right is, isn't that Y inversions? So, number of inversions, until now merging is not started. Before merging, number of inversions left side X, number of inversions right side Y. Just add these two. Afterwards, while merging, some more will come. Some people are asking, sir, what you want to say? Same thing, see, same thing. When you are merging these two, number of inversions, left how many? Add. Right how many? Add. Then while merging, some more will come. Right? Same thing here also. When you are merging, right, left how many inversions? 1. Right how many inversions? 0. So 1 plus 0. First add. Afterwards, while merging, some more will come. Right? Same way. Right? See this one. I want to merge both of them. For the number of inversions purpose, I want to merge both of them. Before going to merge, left how many inversions? Right how many inversions? Add first. So let me write now. Number of inversions is equal to left plus right. First add both of them. If in the place of X, I written L. In the place of Y, I written R. See this one. Number of inversions as of now is equal to left how many plus right how many. Right? This is the left how many plus right how many. Add both. After adding, this algorithm started. Right? Merging is started. Can you help me now? Right? Can you help me now? Left group is from where to where? I to mid. Left group is from where to where? I to mid. Right group is from where to where? K to J. You please help me. If the left group is from I to mid, right group is from K to J, can you say left hand side how many elements there? Left group is I to mid. Left hand side how many elements there? You know formula. What is the answer? Mid minus I, right, plus 1. This is the formula. Left hand side how many elements as of now? As of now, what is the I value and mid value? Just calculate. Last one minus first one plus 1. That will give number of elements on the left. Number of elements right how many? J minus K plus 1. You know this very well. Right? Let's start here. Everything ready? Number of inversions before starting merge algorithm is equal to L plus R. right? Now let's start this algorithm. Can you say, when you start this algorithm, you only say this condition true, this AI is less than AK. This is true means who is smaller? This condition true means who is smaller? Who is smaller? AI less than AK means who is smaller? AI is smaller. Smaller one you will store in the B, that is also okay. But one thing is true. Small is coming from, right? Small is coming. AI is smaller, it's okay. Small is coming from left side or right side? Left side. You only say left side index is less, value also less. So it is not inversion. If is not inversion, AI less than AK condition is true means small is coming from left side where index also less. So it is not a inversion. This is not inversion. This is inversion. Right? When you come to the else part, what is the meaning? AI less than AK fail. What is the meaning? AI bigger. See this one. I index is less, but value more. Right? That means inversion. This area is inversion. If you come to this area, no inversion. If you come to this area, inversion there. Can you help me now? If you come to this area, inversion there. See this one. Number of inversions is equal to. Otherwise, I will use different color. See this. See this one. Number of inversions is equal to, already number of inversions how many? Left plus right already you added. Number of inversions already left plus right already you added, right? Now plus some more will come. Now number of inversions is equal to, if you came to this area, right? Number of inversions, right? Some will come. How many? Number of inversions is equal to number of inversions, existing inversions plus. Next. If it is an inversion, how many inversions will come? Left hand side, as of now, how many elements are there? Those many inversions. What is the answer? Number of inversions as of now is equal to number of inversions already existing plus, what is the answer? Mid minus I plus 1. Right? Left hand side, how many elements are there? Those many add it. Right? This is the inversion area. Before going to start this also. Number of inversions is equal to left how many plus right how many? This one plus this one, right? These two lines, this line extra, this line extra. If you add these two things, right? This particular algorithm will give number of inversions. Lastly, return number of inversions. It will return the inversions. It will merge also. Okay, I am okay. It will return number of inversions also. Can you help me now? Normal merge algorithm, this merge algorithm difference. What is the answer? In the else part, just write this line. Before starting, just write this also. Number of inversions is equal to left plus right. Afterwards, normal merge algorithm. But in the else part, write this. What this Ni? Before starting merge algorithm, already inversions how many there? Those many plus. Now every time something will be added. It is the loop. Every time Ni is updated. First time is Ni before algorithm starting, left plus right. Afterwards, every time Ni plus this one will goes to modified Ni. Ni means number of inversions. It will continue. Please help me. This algorithm. What is the name of the algorithm? Merge algorithm. Can you help me now? This is inversion or no inversion? This is inversion. This area is inversion. This is inversion. No inversion here, inversion. Now can you help me? What is the name of this algorithm? Merge algorithm. Merge algorithm time complexity, both are 50-50. What is the answer? N by 2 plus N by 2, which will goes to N. If both are unequal, M plus N. If both are equal, right? N by 2 plus N by 2, N. Some people are asking, sir, why? After this while loop is over, remaining elements you have to copy. Every element should be moved. Even though this loop is over, this is not over. Remaining copy here. This is over, this is not over, remaining copy here, right? But one line extra, see, merge algorithm, whenever merge sort is going on, merge algorithm clearly explained, same merge algorithm, nothing changed, this line extra. You only say, one line only increased, because of that one, how time complexity will change? Who will decide the time complexity? Loops only, see, loop not increased, loop not decreased, same loop, everything same, one line extra. Right? One line extra. Are you comfortable now? If you are really comfortable, right? If you are really comfortable, now give the answer to me. See this one, now give the answer to me. I think merge algorithm is going to be N by 2. Now say. This one, see this one. According to merge, this one and merge sort same. First to divide, right? Next one is conquer, next one is combine. Now say the story. Final conclusion. Say the story here. See everyone. If someone will give one array, see everyone now. If someone will give one array, if they ask you in this array, count number of inversions, what is the first step you will do, right? If someone asks you in this area, count the number of inversions, forget about small problem. What is the first step? Divide. Yes, I divided. Can you help me? Division will take how much time? Time complexity Tn is equal to, division will take how much time? Simply divide. Mid is equal to I plus j by 2. What is the answer? Constant. First divide. After division is over, there is a left half, there is a right half. Two parts there. So using recursion, solve the left half, Tn by 2. Using recursion, solve the right half also, Tn by 2. Right. So using recursion, I completed the left half. Means inside this one there is a recursive call, merge algorithm, all the things are there. Left side, see this one. See, left side means this part. This is the left side. Using recursion, complete the left. When you say using recursion, left one is completed, this will take Tn by 2 time. This will take Tn by 2 time. When you say Tn by 2 time is over, what happened is, right? So, see this one, sub-array sorted will come and number of inversions also will come from this side. Tn by 2 time is completed, left half completed. What is the meaning? Left half sorted array will come, right? Left half number of inversions also will come. And once again, whenever one more Tn by 2 over, right half sorted array will come and number of inversions also will come. Now see. Right? After division is over, constant, left using recursion solve it, you will get the sorted sub array plus number of inversion. Here also sorted array, number of inversions will come. Now, right, merge them using this algorithm, merge them, right? While merging, please take care about number of inversions also. This will take how much time? N time. N by 2 plus n by 2, n. Finally, 2t n by 2. N by 2 plus n by 2 is 2t n by 2. Constant plus n will leads to n. Finally, which will goes to 2t n by 2 plus n, right? So, using, I think, substitution method, do log n time, right? This will goes to big O of n log n, right? Every case. From today onwards, if anyone asks you how to count number of inversions in the given array, what will you say? Simply merge sort. They will ask you, using merge sort, how can you count the number of inversions? What will you say? Exactly merge sort only in the merge algorithm. Write one line extra. What is that one line extra? This line extra. Right? Next one, before starting merge algorithm, this line also required. Number of inversions as of now is equal to left plus right, how many? Plus, while merging, few more will come here. These two lines you write, right? Then in the existing merge sort algorithm, right? If you do two changes, one or two changes, that is not a major one. Major change this only. That is the reason I am saying one change. Actually, one change only. But anyhow, two lines you have to write extra. This one and before starting. In the existing merge sort algorithm, if you do small change, then it will give number of inversions also. Merge sort, this one same. Time complexity, everything same. Just one more extra variable you keep, ni. Now, can you help me now? This problem. Counting number of inversions problem. If you do manually, n square, right? If you do using divide and conquer, this approach, what is the answer? N log n. And one more thing I want to ask you. What is the stack space? Log n. What is the extra? Because of merge algorithm you are using, right? Extra space is going to be n because B array required. If you want, you can check. It is the time complexity. Tn is time. Please be careful. Tn is time complexity. Right? Let's see that also. Extra space is equal to, what is the extra space? Right? Here 2 extra space. What is that one? I think merge algorithm. B array, n bytes. Next one, stack space. How much? Divide by 2 log n. Overall n. Same thing like merge sort. Next application of divide and conquer is quick sort, right? I written on the board also, please see. Right, and one more thing, right? In GATE examination, compulsory question, either quick sort or merge sort. I mentioned already in the last lecture also, merge sort mostly will come in GATE examination, right? If not merge sort, quick sort, it is confirmed. I am saying to you. If see this one, quick sort, merge sort, guarantee one will come. If you are lucky, both will come. Suppose that in both, right, nothing came, you can file a case also on me. I will go to jail. Really I am saying to you, quick sort, merge sort in GATE examination compulsory. Any one will come or both will come. If not, you file a case on me. I will go to jail. and I will file a case on that person also who framed that question paper. Because I never seen any question paper until now without having these two things, right? Please be careful. That much important. I want to say indirectly, directly, right? These two topics are that much important. If you know MedSort, you know QuickSort also. But one thing is to comparing the MedSort, QuickSort may be having little bit some more nice topics, right? Anyhow, okay. I want to say finally, this is also important. Please you take care. Listen properly, listen properly. If anyone thinking that, sir, I will read the QuickSort myself, if anyone thinking like that, if you open any book, right, there is one book, Core Man, I said to you, if you open the QuickSort purpose, that book, it may contain approximately 100 pages for QuickSort only. 100 pages if you keep on reading, I am really saying to you, at the end of the 100 pages, right, you will stop preparing GATE exam also. Please be careful. 100 pages for one topic purpose studying, there is no meaning in that. So those 100 pages, you need only 5 pages only required. I will explain clearly, right? Please listen. From now onwards, please concentrate. Right? I written something about the QuickSort also. Please see. First one, QuickSort is practical sorting algorithm. Second one, it is an in-place algorithm. Third one, it is not stable. It is not stable. These are the 3 points. Right? Can you help me one small line? What is the meaning of not stable? Right, I said to you in the last lecture, I said, right, MedSort is stable, but it is not stable. What is the meaning of that one? Right? So, in the given array, there are some repeated elements. Assume that there are 2 10s are there, 10A, 10B. In the given array, there are 2 elements. In the given array, so many elements are there. I am talking about one element, that is a 10, which repeated twice. In the given array, there are so many elements. One element is there 10 which repeated twice. Assume the first 10 is 10A, assume. Second 10 is 10B. First 10 is 10A, second 10 is 10B. Right? This is the current status. After sorting is over, those two numbers will come side by side. But it cannot be 10B, 10A. It should be 10A, 10B only. In the input, repeated elements order how it is. Right? In the output also, after sorting also, repeated element order should be same. Then it is called stable. Otherwise not stable. QuickSort is not stable. It is not a great drawback, but they want to say this. Some people are asking, sir, how it is a drawback and all. You know very well, right? So 2 10s are there. After sorting, they both will come side by side. Why are you swapping unnecessarily? 10 10 anyhow. Why are you unnecessarily swapping? You may swap unnecessarily. It is not a great drawback, so that is not a big problem. That is the reason. QuickSort is going to be practical sorting algorithm. Some people are asking, right, QuickSort practical sorting algorithm, what is the meaning? The meaning is going to be, as a computer science student, when you are doing any project, inside that project, if you need a sorting algorithm, people normally will use QuickSort only. While doing project, inside sorting technique required, people normally will go for QuickSort only. Right? That is the reason it is called as a practical sorting algorithm. Means if you really need sorting, then go to the QuickSort. That is the meaning of that line. If you really need sorting, right, then go to QuickSort. That is the meaning of practical sorting algorithm. It is not theoretically sorting algorithm, practically sorting algorithm. What is the meaning? When you want to implement sorting technique, right, then people normally will prefer the QuickSort only. Next one more thing. It is a in-place algorithm. Great thing is it is an in-place algorithm. What is the meaning? MedSort is not in place. It is a in place. What is the meaning of that line? This algorithm don't take extra space more than log n. So QuickSort is in place. MedSort is not in place. You know this very well. You will see the proof also. Some people are asking, sir, how? You will see the proof also. And one more thing. Why it is practical sorting algorithm is, try to remember, right? Among all the sorting techniques, it is a faster sorting technique. That is the reason name is given a QuickSort. See, quick. It is a faster. In all the sorting algorithms, whatever you will study, until now you studied 1 or 2, right? So further you will study more, right? Among all of them, the faster sorting technique is going to be QuickSort. Some people are asking me, how can you say that? Name itself saying, so I am not saying, see the name. QuickSort. It is the faster sorting technique. That is the reason it is a practical sorting algorithm. Not only it is the faster, and one more thing is what? It is in place. Some students are asking me, sir, if you say it is a faster sorting algorithm, how much time complexity it is taking, right? Try to remember, this will take n log n time, right? Merge sort also will take n log n. Both are n log n. Some people are asking, if both are n log n, how can you say it is a faster? Suppose that both are n log n, asymptotically both are n log n. That may be 5 into n log n. This may be 2 into n log n. Constant factor, right? Quicksort is faster. Asymptotically both are n log n, but mathematically if you observe, that may be 10n log n, this may be 2n log n. Constant factor, this is faster, right? In asymptotic terminology, right? Asymptotic terminology, 10n log n, 2n log n, both may be looking same, but everyone know 10n log n and 2n log n. What does it mean? 10n log n is going to be, I think, 5 times bigger. 5 times bigger means 5 times it will take more time. So finally I want to say to you, it is a faster algorithm, time complexity n log n, but still it is faster. What is the reason? I think merge sort will take constant factor more time, right? This will take less time. And not only that, merge sort is not in place, but it is in place. Okay, few points I want to cover, I already written, I explained also. If you want to see the proof, how this algorithm look like, right? Within few minutes you will get the clarity. Let me repeat once again, say something about quicksort. What is the first one? It is the practical sorting algorithm. Means, if anyone really needed sorting technique, right, in their development, people normally will go for, right, quicksort only. Next one, it is in place algorithm and it is not stable. It is not stable, it is not a great drawback, but anyhow it is not stable. But why stable concept is a drawback, right? You only say same elements are coming, right? Same elements are coming side by side, but why you unnecessarily swap? You will swap unnecessarily, but merge sort don't swap. Merge sort is going to be stable, it is not stable. Okay, whatever you got, it's okay. Now I am starting now. And one more thing, quicksort is the one of the application of divide and conquer. Here also divide, there something like that. Total divide and conquer, right? It is also following the divide and conquer kind of behavior. So if you want, I will write that also. It is one of the application of divide and conquer. It is the divide and conquer application. It is the divide and conquer application. Right? These are the 4 points if you are okay. Now let's go to the next one. So definitely I will give the proof also. I will explain each and every point. Right? Quicksort faster, that is the reason everyone using. Name itself saying quick, right? Please be careful. Right, let's go to the next one. Let's go to the next one. Now see, interesting thing is coming. Listen, interesting thing is coming. Everyone listen this point, interesting point. Right? Listen correctly this point. Quicksort and merge sort, which is the divide and conquer application? Quicksort, merge sort, which is the divide and conquer application? Both. Both are divide and conquer application. Means what they will do both. What both will do? Right? Try to remember. Quicksort also, merge sort. In both the cases, small problem there. It's okay. If small, you know that story, you know. If it is big, come to the else part. If it is big, right? If it is big, merge sort also will divide. Quicksort also will divide because both are divide and conquer application, right? So in both the cases, because of both are divide and conquer application, if the problem is big, merge sort also will divide, quicksort also will divide. Can you help me now? Who will divide? Both. Both will divide. But try to remember, both will divide, it's okay, but merge sort will divide blindly, but quicksort will divide meaningfully, right? Please be careful. Some people are asking, sir, how, right? You will see within few minutes. Right? One more interesting answer, right? Who will divide? Both. Who will divide blindly? Merge sort. Who will divide meaningfully? Quicksort. Then what is the advantage you will get? Because of merge sort is doing blindly division. Because of it done the blind division, right? Compulsory you have to combine also. You have to merge it. You have to combine also. Because of it done meaningful division is done. You no need to combine. In quicksort, no combine. What is the reason? Division time itself you are so careful, then why you combine? But in the case of merge sort, division time blindly divide, you have to combine. Try to remember, right? Division time or combine time, somewhere you have to take care. So some students are asking, sir, here combine there, here combine not there. Here divide there, here also divide there. Some people are asking, sir, what actually going on? Try to remember, these two are the two sorting techniques. In one sorting technique, in merge sort, what they done, division time they are not taken care that much, but combined time they are taken lot of care. But in the case of the quick sort, division time itself they will take care, combine not there. Right, combine not there. Please be careful. It is something like this. It is some, if I want to say in the easiest terminology, it is something like this one. Right. So you are on the main road, assume you are on the main road, right? So you are on the main road, left side you are. You want to go to right side. You are on the main road, you are on the left side, you want to go to right side. Means you want to cross the road. Right. When you are crossing the road, what some people will do is, they will carefully cross the road. Right? They want to cross the road. Some people what they will carefully cross the road. What is the meaning of carefully cross the road? They will check both the side vehicles are coming or not. If vehicles are not coming, then they will move. Carefully they will cross. What some more people will do is, they want to cross, they will directly cross. If you directly cross, what will happen? Right? Vehicle also will cross you. Right? There are some people who will cross the road blindly. There are some people who will cross the road, right, meaningfully. What is the meaning? They will see both the sides, they will take some precaution, then they will cross. Both will cross the road, but one person crossing blindly, one person crossing meaningfully. So when you, those people who are crossing meaningfully, what is the advantage? They don't go to hospital. But those people who are crossing blindly, they have to go to hospital also. In the hospital, they will take care a lot. Some people will take care starting, some people will take care at ending. Please be careful. Who will take care about starting? Nice people, nice human beings. What they will do is, they will take care starting itself. Crossing itself they will take care, so that no need to go to hospital. But some people, right, crossing time they don't take care. Right? After crossing over, then they will take care. In hospital they will take care. Different kind of behavior. So last time I want to ask, who will divide? Both. But what is the difference? Right? Some people will divide blindly, some people will divide meaningfully. Blind division is called merge sort. Meaningful division is called quick sort. Is there anyone who remembered merge sort time complexity for divide? Merge sort time complexity for divide. What will happen? Mid is equal to I plus j by 2. Merge sort time complexity for divide is simply one line. Mid is equal to I simply do half. So n elements are there. Merge sort algorithm if I ask, right? So divide. What the merge sort algorithm will do is, out of those n people, left half, right half. You don't compare also. What are the elements are there inside? You don't compare. Totally n elements, merge sort saying that divide. So 50-50. You don't check also. But if I ask the quick sort algorithm, n elements are there, divide. Quick sort algorithm will do meaningful division. So means you will ask every person. You will ask every person. Accordingly they will divide. Quick sort will do meaningful division, right? Merge sort will do blind division. Last time I want to ask, who will divide? Both. Who will divide blindly? Merge sort. Who will divide meaningfully? Quick sort. Can you say what is the meaning of blind division? Blind division means you don't bother in that array what elements are there, what elements not there. Simply half this side, half that side. Can you say what is the meaning of meaningful division? Meaningful division means it will ask everyone, right? What is your value? You are small or you are big, like that. You have to scan total array, then they will do. By taking all the people opinion, if you do division, that is called meaningful division. Without taking anyone's opinion, if you blindly divide, that is going to be blind division. That is going to be blind division, right? Please be careful. Now next, one more interesting answer. Meaningful division and blind division, which will take less time. Everyone know, blind thing guarantee will take less time. Blind is simply, right, 50-50, that's it. But when you say meaningful division, you have to ask all the people, it may take more time. So merge sort is going to be blind division, means mid is equal to I plus j, one single line only. Because of that reason it will take less time, but one thing, afterwards problems will come. But in the case of the quick sort, meaningful division, it will ask all the people, so it will take more time. Now some people are asking, so here divide, in the case of the quick sort, divide is costly, in the case of merge sort, right? Divide is, right, less, cheaper, you can say, right? Quick sort division is costly, merge sort division is cheaper. Cheaper means what? Less cost. But some people are asking, then how can you say quick sort is better and all? Afterwards, if you see in the quick sort, no combine. Here, afterward, there is a merge algorithm which will take a lot of time. Someone is careful starting, someone careful at ending. Who is better? Starting only. What is the reason? So, if you are careful starting itself, you are not wasting some resources. right? Those people who are not careful at the starting, at the end maybe you will do. If you are not careful at the starting, at the end maybe you will do. You maybe become successful at the end also. Some people are asking, sir, finally I want to be successful. Starting I am careful, ending careful, how it matter, right? Suppose if you are not careful at the starting, right? If you careful at the ending, it is something like this one. Your age become 90 years, 90. That time you became richest person. What do they use? Right? Your age became 90 years, that time you became richest person, what do they use? There are some people at the age of 35 years only, they became richest people. What is the reason? Mostly they are not done any mistake. If you do very less mistakes, right? So within less time only you will occupy the topmost place. Right? If you want, you can verify. Right? I think, right? Facebook CEO, maybe mostly is not done any mistake. Within less time only, right, he occupied in the industry topmost place. Some people occupied the topmost place at the age of 90 also. That is also okay, this is also okay. But if you do less mistake, if you don't do mistake starting, within less time only you will occupy the topmost place. Now again I am repeating now. Listen, again I am repeating now. Quicksort, merge sort, say the differences. Quicksort, merge sort, say the differences. Both belongs to divide and conquer. Both contain division. Both contain division, but one will be careful at the division, that is the quicksort, right? He is not, merge sort is not careful at the division, right? That is going to be blind division, that is the merge sort. Fine. Because of he is blindly dividing, merge sort, right? Afterwards you should be careful. Merge time he will be careful. Merge time he will ask every person. But in the case of the quicksort, division time itself is doing meaningful work. There is no combine further. Now can you help me now? Quicksort, merge sort, which is the divide and conquer application? Both. But quicksort is a partial divide and conquer application because there is no combine. Right? Fine. Okay. Whatever you got, it's okay. Now it's the correct time to ask you. In the quicksort, if I want to explain anything, what I have to explain? Right? How meaningful division is done. That is the only thing I have to explain. After division is over, there is a conquer. After conquer, there is no combine also. That is the reason in the quicksort algorithm, if you learn how meaningful division is done, then quicksort almost you got. In the merge sort algorithm, blind division, but everything done by at the time of merging only. If you want to know something about the merge sort algorithm, merging you should be clear. Merge sort is major part is merging, quicksort major part is division. Right? Division. Some people are asking, quicksort major part is division. What is the name for the division they are given? That algorithm name is called partition algorithm. Name itself saying partition. It will divide. Partition means division. Right? Partition algorithm. Right? Quicksort performance is completely based on partition. Merge sort algorithm total performance is based on merge algorithm. You know merge sort means you know quicksort also, but here he will take care about the division time itself. He will take care about the combined time itself. Anyhow, you know merge sort very well. Let's go to the quicksort. Quicksort, what is the major story? Right? Partition algorithm. Let me write now. Partition algorithm. Until now, whatever theoretical things you got until now, it's fine now. Let's see the partition algorithm. Quicksort major one is partition only. Right? Partition algorithm. Right? I will write now. Let me write. Partition algorithm. Partition algorithm purpose is dividing the given array into two parts. Right? How he will divide? I will write the algorithm. After writing, I will explain. Right? Fine. See the partition algorithm. In quicksort, major one is partition algorithm. I written on the board. Right? See the partition algorithm. Partition algorithm. So this is the one. So you may be thinking that I by-hearted partition algorithm and all. Really not required. If required, I could have by-hearted. Right? Just I written normal way because I know the logic. Right? I know the logic how the partition algorithm is working. When you know as a computer science student, by heart the logics. Okay, this is the logic. Right? Don't by heart the code and all. By heart the logic, automatically code will come. I may be written here for loop. Some people will write while loop. Right? Some people will write some other way, but logic is same only. Different books contain different partition algorithm. If you want to, you take some other book. Right? Some other book contains some other partition algorithm. This partition algorithm I studied in one of the book. Right? Everything is okay. I got to know book to book partition algorithm way of writing is differ. Way of writing is different, but finally indirectly, directly all are doing same story, right? So just learn one partition algorithm. This partition algorithm you learn. Everything is okay. This partition algorithm you learn, right? So I will say the logic, right? Carefully you observe, so that no need to by heart also. Otherwise you have to by heart. But when you are doing by hearting, no use. I am repeating once again. I will explain carefully this partition algorithm, right? So if you follow that one partition algorithm, directly you will get. So otherwise you have to by heart this algorithm. When you by heart, no use is there. With by hearting, right, what will you achieve in the life? Nothing there. It is not English grammar to by heart. It is not something else, right? Everything is logics only. Just I think, okay, partition algorithm is like this, right? Try to get the partition algorithm. Afterwards, after partition algorithm, my explanation is over, right? You see this algorithm. Easily you will get. Without this algorithm also I can explain, right? But anyhow, it's safe side, it will be useful, right? Let me keep there, right? Let me keep. Can you help me one small line? In this partition algorithm, if you observe, see this partition algorithm, if you observe, is there any for loop? Yes, for loop is there. When you say for loop, time complexity, some time complexity means loops only. When you say there is a loop, time complexity will be there. And one more thing, this loop is how many times? Let's check properly. And one more thing, partition algorithm is a, right, blind division. Partition means division, that's okay. Partition algorithm is a blind division or a meaningful division. What is the meaning? Meaningful division means, right, it will ask every person, how many people are there, everyone it will ask. If you take very big, if you see some big companies, in the big companies, if they want to take any decision, right, mostly they will send one mail to all employees, or board of directors will sit together, right, they will talk. So if you take many people opinion and if you take the decision, right, that will stay many days. That is called meaningful decisions. If you take blindly, right, it may work, may not work. Meaningful decisions are always like that. You have to contact many people. Maybe all employees, you can send one mail. You can ask, we want to do like this one, what is your opinion? All the board of directors will sit together, they will talk. So some discussion should happen, means all people should participate. If you do blindly, like merge-sort algorithm, because of blindly you done, there is a big story of merging. Here there is no merging, the reason is here not blindly. Can you help me one small and partition? See this one, both people will divide, but this division is costly or not? Yes. Why? This is the meaningful division. Many people will participate, so it will be costly, right? Merge-sort division is going to be, right, little bit cheaper, but the problems will come afterwards. Here, after these problems will solve. Anyhow, let's come here. Can you help me in the partition algorithm? Is there any loop? Yes. Can you help me now? This loop is going from where to where? Let me check here. See this one. Partition algorithm input. Carefully you listen. Can you say partition algorithm input? What is that one? One array. Output, it should divide the given array into two parts, right? That will be the final output. See this one. Partition algorithm input is going to be one array, output is going to be dividing the given array into two parts. So array means what? Array A which contains P to Q. What is the P to Q? P is the first element position, Q is the last element position. Assume that array contains 1 to 10 element. P is 1 position, first element position, Q is 10, last element position. So array A which contains P to Q elements, you want to apply partition algorithm, right? See the first step. In the partition algorithm, first step is going to be, right? So partition algorithm first step is going to be, suppose on this array, if someone asks apply partition algorithm, first step is going to be in that array, select one element. Partition algorithm first step is going to be, if someone say to you from today onwards, on this array apply partition algorithm, if someone say to you, just immediately ask them, right, in this array which element I have to select, ask them. If they say take anything, you take anything. So first step is going to be in the given array, select one element, because partition is done with respect to that element. Right? The element which you select, with respect to that element only division is done. That element is called as pivot element. Right? That element is called pivot element. If you want, I will write also pivot or pivot or pivot or whatever it is. So in the listen everyone now, in the quicksort algorithm, major thing is partition. In the partition algorithm, first step is going to be select one element, right, with respect to whom you want to divide the given array. That element is called as a pivot element. pivot element. Now see this one. What is the P? First element position. What is the Q? Last element position. Now see this one. A of P, first element. First element is X. What is the meaning? First element they selected as a pivot element. X contain first element, not first index, first element. X is equal to A of P. What is the meaning? X contain first element, which is nothing but pivot element is X. Please be careful. Right, that is the first step. After selecting the first element as a pivot element, now see this one. I is equal to P. What is the P? First element index. Right. So P means first element index. Right. So I also same. In the same place both will be there. In the same place both will be there. Afterwards one loop is going on. Can you help me one small line? Loop is going how many times? Let me check. J is equal to P plus 1 to Q. P plus 1 to Q. Assume that this is 1. This is 1. Right? This is assume that 10. P is the 1, Q is the 10, assume that. Can you say what is the J? P plus 1, 2, Q, 10. So this loop is going on 2 to 10 times. Means how many times? Array contain 10 elements. This loop is going on 2 to 10 times. What is the meaning? 10 minus 2 plus 1, you know. First element index 2, last element index is 10. So the number of times present from 2 to 10 is going to be 10 minus 2 plus 1. I think 9 times. 9 times this loop is going on. If the array contain 10 element, this loop is going on 9 times. If array contain n element, this loop is going on n minus 1 time. This for loop is going on n minus 1 time. Some people are asking, this for loop is going on n minus 1 times, it's okay, but every time, with which element is comparing? See this one, J value 2, first 2, A of 2 compared. Afterward J value 3, A of 3 compared. Every time, every element is compared with the X, which is the pivot element. Can you help me now? Partition algorithm first step. Select one element as a pivot element. You selected, right? Division is done with respect to that element. Because if division is done with respect to that element, everyone should be compared with that element only. So which element you selected as a pivot element? First one. That will be compared with all other elements. First element is compared with all other elements. With whom you want to do, with respect to whom you want to do partition, that element will be compared with all other elements. Accordingly, you have to take the action. Right? Please be careful. So loop is going on. If this condition is true, then I is equal to I plus 1 swap, something like this is there. So this is the algorithm, right? Just roughly I explained. Within few minutes I will take example, everything okay, don't worry. Right, I am starting. Can you help me now? Before going to start this algorithm, just let me ask you a few questions. Let's see the algorithm and talk. Partition algorithm input, one array. Next one, to that array, right? What is the starting element index? P. What is the ending element index? Q. That's fine. Next one, in this algorithm starting step, select one element which is the pivot element. Any one you can select. Next one, after selecting one element as a pivot element, that will be compared with all other elements, If you take first element as a pivot, other means what? Second element to until last element, everyone will be compared with the pivot element. Accordingly, you take the action, right? Like that. I hope everything fine. Now, whatever I said until now, I will do with the help of one numerical example, everything okay. I will do one numerical example, you do one more numerical example, that is fine. So let me do this. And one more, this loop is going on how many times? N minus 1 time. If this loop is going on n minus 1 time, please check inside the loop. This loop is going on n minus 1 times, it's okay. Please verify yourself. Inside the loop, is there any return? No. Is there any exit? No. Is there any chance of stopping in between? No. This loop compulsory have to continue n minus 1 time, every case. What is the meaning? Partition algorithm time complexity, every case, right? N time. Indication that this loop compulsory, you cannot escape from this loop. Partition algorithm, in the partition algorithm, pivot element is compared with all other element. All other means how many? N minus 1. So n minus 1 times this loop will repeat. So which is nothing but time complexity big O of n, every case, please be careful. And one more. So what is going on here? Clearly I will explain with the help of one numerical example. See this one. Whenever I am explaining, one small doubt also there, algorithm also there. As a CSC person, algorithm is there, easily will get it. Only for namesake I written this one, still at anywhere you have doubt, you can refer it. Some people are saying that, sir, in another book some other partition algorithm is there, it is none of your business. You are not doing the research in this subject. One partition algorithm, please learn. Right? So partition algorithm to partition algorithm, small changes are there, but most, right, if you see the inside story is same, right? Don't worry. So I am starting now. I am starting. One example for this. See this one. First example maybe. 3 examples I will give. First example I am doing. See everyone. Array A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, array A which contain 1 to 9 elements. Let me give the values. Let me give the values. Let me give the values here. 50, 80, 70, 60, 35, 89, 25, 66, 43, some values, right? One array I took, right? In this array these are the elements, totally 9 elements are there, right? Now I am applying partition algorithm. Can you say what is the partition algorithm purpose? Dividing this array meaningfully. Dividing this array meaningfully means with respect to what? So you have to select one element. Can you help me now? According to the partition algorithm, can you say which element I will select a pivot element? Select any one. Normally which one people will select? First element. Select the first element as a pivot. Let me select it. See everyone now. First element. Can you help me now? What is the P? What is the P? First element index 1. What is the Q? Last element index 9. Right? Try to remember. Q is not 43. Q is 9. P is not 50, P is 1, indexes, please be careful. Next one, can you help me now? In this algorithm, first step, what is the answer? Select one element which is the pivot element. Yes, I am selecting first element. So what is the answer? X is equal to A of P. P is 1, A of P means A of 1, 50. X is 50. Right, this is completed. Next one, I is equal to P. Whatever P, I also same. That is also okay. Next one, loop is starting, right? J is equal to. Loop is starting from P plus 1. P is 1. P plus 1 means I think it is 2, so I think J is here. So loop is started from here, see. J is equal to P plus 1. P value 1, 1 plus 1, 2. This is the current status. Now, listen now. Before going to start this algorithm, I will ask a few questions, please say. Can you help me now? See this input and talk. See this input and talk. Before going to the major story, just I am asking you. Can you see this array and talk? Right? Can you say what is the P? In this problem, what is the P? 1. Position. What is the Q? Last element position 9. What is the I? First element position 1. What is the J? Second element position 2. What is the X? Pivot element 50. Like that. These are the total 5 variables. Repeat again now. P 1, Q 9, I 1, J 2, X 50. Right? These are the things. And one more. After keeping like this one, just I want to ask you one small line. Careful listen. Just I want, after keeping these 5 people, just I want to ask one small line. Can you say what is the I? 1. What is the J? 2. I is 1, J is 2, that's okay. Can you help me in the I and J, who is right side? J. I left side. In I and J is right side, I is going to be left side. Try to remember. So in the I and J, I left side, J right side, it's okay. Right side person J saying that I want greater. Right, you want greater. J saying that I am right hand side, I want greater. Some people are saying greater what? What greater? Right? More than pivot. Everything is comparing with the pivot only. J saying that I want greater than pivot. But I saying that I want, right? I is saying that I want, right, less than pivot or equal to pivot. This is the discussion which is going on. Can you help me now? What is the I as of now? First position, right? 1. What is the J? Second position. Can you help me? I and J, who is their right side? J saying that I want greater. I saying that I want smaller or equal. That is their goal. Right? I said very clearly. I said to the J, you take care about greater. I said to the I, you take care about smaller or equal. Like that. Now see this one. After saying that one, can you, if you observe clearly in this loop, who is changing every time? Who is changing? J. J value 2. First J value 2. Afterward J value 3. Afterward J value 4. This loop is going on until how many time? Until 10. In this loop always J is changing. This one, in this loop always J changing. Sometimes I will change, but every time J will change. I may change, may not change, but J will always change. Please be careful. Now can you help me? Now this loop is going on. Who is changing every time? J. Sometimes I also. Please be careful. Now again I am asking you. Again I am asking I, J. Who is on the right? J. Left, I. Can you say what they are decided? Before starting algorithm itself, what they decided? J saying that I am right side, my goal is greater than pivot. I saying that I am left hand side, my goal is smaller or equal. Right? Next one. So after deciding the goals and all, now loop is started. J saying that, right? Because of, right? In the loop I am only there. I will always check. J is saying to I, whenever this loop is going on, every time I will check. Every element I will check. J saying that I want the greater people, it's okay. But whenever this loop is going on, I will always change. What is the meaning? I will see every element. Right? Accordingly, I will take the action. They both compromise. What is the compromise? I saying that I want smaller or equal. J saying that I want greater. Now J said one more line, right? In the loop, I only moving every time. J saying that in the loop, every time I only moving at anywhere, right? Every time I am keep on moving, so I know what is there, what is not there, right? If at all greater will come, I will take. J saying that if because of I only moving every time, if greater will come, I will take because I want greater. If smaller will come, I will inform you. Right? This is the discussion which is going on. Let's start now. Can I say who is moving every time? J. J saying that I want greater. If I get greater, I will take. If I don't get greater, if I get other than greater, I will inform to I. Like that is going on. Now start the loop. Can you say J value 2? Right, 2. 2 less than or equal to Q, true. Then come inside. Inside means what? Right, after coming asking. See this one. Inside if condition. See, J is asking this person. J is 2, J is asking this person. I want more than pivot. Are you more than pivot? Yes. J saying that I want more than pivot. Are you more than pivot? Yes. If it is more than pivot, let's check here. A of J, 80. 80 is less than or equal to 50. Condition true or not? Condition is fail. So out of this loop. What is the meaning? J saying that I want greater. E saying that yes, I am greater. Whatever E want directly there, then why he will do extra work? Can you help me? This condition is true or false? False means what? Out of if means you are at here. Means no work. Whenever this condition is fail, no work there. Then you will come here. You will again go to this place. Can you help me? J is asking, I want greater. Are you greater? Yes. Whatever he want, he got. Then no work is there. Then happily he will say, because of I think I got my required thing. No work also there. Then J plus plus. So J will go to next. Again J will ask, are you greater? Yes. J saying that I want greater. Yes, you are greater. So no work is there. Whatever I want, I got immediately. We will work. So J is equal to J plus 1. Again, are you greater than pivot? Yes. Right? Then go here. Are you greater than pivot? No. Are you greater than pivot? No. See this one. A of J 35. 35 less than or equal to 50. Yes. When J saying that, are you more than pivot? He said no. Means this condition is pass. What is the indication? This condition pass, what is the meaning? J saying that, are you greater than pivot? E saying no. Indication that J want greater, but greater is not there. What is the meaning? It is smaller. Now can you help me one small line now? It is smaller, it's okay. Who wants smaller actually? I and J both compromised starting. What the I said to J? I said to the J, you please move yourself. You only move. I said to the J, you only move in the loop every time. You only see every person. Anywhere greater you take. Anywhere smaller inform to me. Can you help me now? J is stopped here and J is asking, are you greater? He said no. Means small came. Now J remembered immediately. Okay, I is waiting for that. Right? I is waiting for that. Whenever J got smaller, J will inform to I saying that, hello I got smaller. Which you want. Right? I will give to you. Then whenever J is informed to I got smaller, please you take, right? But J will say one more also. I got smaller, but I want greater. You take smaller and, right? You take smaller, but you give greater to me return. Then we can swap. J is ready to give small, right? But J said to the I will give small to you, but you have to give greater to me. Then I can swap. I don't give freely, right? So you want smaller, I have smaller. It doesn't mean that I will give freely. You take smaller, you give greater to me. So what does it mean? This condition is true. Inside you go. Then whenever J is informed to I like that, I simply say that, right? You got smaller, right? You want to give smaller to me, in return I have to give greater. So what the I saying is, wherever I am, that place greater is not there, but I plus 1 is greater is there. See, I plus 1 is greater. Whenever he got smaller, he informed to I, you take smaller and you give greater. I will say that wherever I am, greater is not there, but I plus 1 is having greater. Yes, right? Then swap them, swap it. If you swap it, it will become 35, it will become 80. So like that, see, increment I is equal to I plus 1, swap A of I, A of j, like that. Can you help me now? Who is moving every time? J. But j and I, what they decided? I saying that I don't move. J, you only move every time. But whenever you got to know greater, you take. Whenever you got smaller, inform to me, right? I will take smaller, in return I will give greater to you. How he will give? I will increment by 1, then they will swap. This is the story which is going on. If anyone having small disturbance also, algorithm also there, please take care. As a CSE person, if you have a algorithm, nothing there to discuss. Little doubt also there, please go through it. One loop is going on, in that loop J is always moving, right? Let's see if any those people who are having doubt. I think after completion of swap, right, again same, J plus plus, J will move further. Again J will ask, are you greater? Yes, no problem. Next one, are you greater? No. Whenever he will say no, what is the meaning? Small came. J informed to I got smaller again. I will say, let me increment by 1, so that I can give greater to you. You can give smaller to me. 25 here, 70 here. After swap is over, as usual, same. Right? J is equal to J plus 1. Are you greater? Yes. J is equal to J plus 1. Are you greater? No. Then I is equal to I plus 1, swap it. It is the 43, it is the 60. After completion of the swapping is over, again same, J plus plus. So J is here. Can you say what is the J now? J until now 9. Now J became 10. Now check. 10 less than or equal to 10. Can you help me? What is the J value? Sorry for this one. What is the Q value? 9. Right? Q value 9. Right? So Q value 9. Please be careful now, as of now. So J is equal to J plus 1. J is here. Can you say until now J value 9. Now J value become 10. 10. Now let's check. J value becomes 10 now, right? 10 less than or equal to 9. Condition is true or false? False. So out of the for loop. Right? J is incrementing. See this one. J is incrementing. What is the J value? Initially 2. J value initially 2. After 2, what the J will do? 2, 3, 4 and so on. J value 9. Right? So 9 less than or equal to 9, true. Right? Finally J value becomes 10 now. Now J value becomes 10. 10 less than or equal to 9, condition failed. Right? 10 less than or equal to 9, condition failed. Can you help me now? Initially Q value 9. J value 2. J is incrementing 2, 3, 4, 5, 6, 7 until 9 pass. Right? 10 less than or equal to 9 fail, means out of the for loop. Simple. Whenever array is over, stop. Can you say who is moving every time? J. When J crosses array, what is the meaning? Elements are over, stop it. Now can you help me at the end of this one, at the end of this for loop, if you observe clearly, in the array 3 partitions are happened, please check. At the end of this for loop, if you see this array, in this array 3 parts are there, right? Please verify. Some people are asking, sir, how 3 parts? Please check. Can you help me now? Right? First element, if you observe, pivot, at the pivot. First element is pivot. Fine. Next one, I think comparison is started from second element, because first one is pivot. Next one, first one is pivot, it's okay. Initially I is here because of small came, I plus 1. Again small came, I plus 1. Again small came, I plus 1. See this one. How many times small came? Those many times I plus 1. Initially I here because of one small, I plus 1. One more small, I plus 1. One more small, I plus 1. Further no small came, so I stopped here. Try to remember. See this one. Whenever I is incrementing, because small came, it is incrementing. Right? Further small not there, it is not incrementing. See this one. Wherever last I there, this area, small or equal. Please check. Smaller, because it is related to I. Small or equal. Equal also same thing will happen. Small or equal. This is the pivot. This is the less than or equal to pivot. And one more. Further I is not incremented. What is the meaning? All are greater. These are greater. These are greater. At the end of the for loop. See, not at the end of the algorithm. At the end of the for loop. This for loop is over. Array will be divided into 3 parts like this. Now please, those people who are thinking that you are comfortable, as of now, can you help me now? Few things. What is the I? Those people who are thinking that at the end of the for loop, You got all the things whatever I said. If you think at the end of the for loop, please let me know few things. What is the P? As of now, what is the P? P is first element position 1. What is the Q? Last element position 9. That's okay. What is the I? I is initially here. It's moved here. I is 4. Next one, what is the J? J is out. J is 10. That's okay. P is 1. I is 4. Right? J is out. Everything is okay. Can you help me now? Listen. Listen. At the end of the for loop, how many parts? Partition. Right? Small or equal. And one more thing is greater. Now, can you help me one small line now? Listen. Can you help me one small line now? At the end of the partition algorithm, which element you will take pivot? Which element you will take pivot? Right? That will go to correct place. That is the goal of the partition algorithm. Goal of the partition algorithm is going to be, after partition algorithm is over, whichever element you took as pivot, right? So that element should go to correct place. What is the meaning? Pivot element will go to correct place means less than or equal to pivot left side, more than pivot right side. You should go like that. That is the meaning of keeping pivot element in the correct place. Partition algorithm is over, pivot element will go to correct place means less than or equal to pivot left side, more than pivot right side. So means pivot element should be in the middle. Pivot element cannot be in the first place. As of now it is there in the first place. Afterwards small, afterwards big. But partition algorithm goal should be pivot element should be in the middle. Left should be smaller or equal, right should be greater. So for loop is over, remaining work will be done by this person. Remaining work will be done by this person. See how he will do. Can you help me now? As of now I 4. As of now P 1. Then what he will do is swap A of I, A of P. Swap it. P is going to be 1, A of P is 50. I is going to be 4, A of I is going to be 43. Right? Swap it. So what is the answer? If you swap, here 50 will come, here 43 will go. Yes, you done the swap. After swapping is over, return I. Can you say what is the I value? 4. After swapping is over, you will return I value which is 4. Right? This also completed. Now can you help me now? This total partition algorithm is over. Now let me write the output. I am writing the output now. Total partition algorithm is over. Let me write the output. See this one? Total output I am writing. 4 is equal to first element 43. Next to 35, next to 25, next to 50. Same, all the elements whatever they just I am writing 80, 89, 70, 66, 60. Positions 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally 9 elements are there, 9. Now can you help me one small one? If you observe clearly, right? Can you help me? Which element you are taking a pivot? Which element you are taken as a pivot? Which element you are taking pivot? 50. See this one. If you take 50 as the pivot element, after partition algorithm is over, 50 will go to correct place. Less than or equal to pivot one side. Please check. All are less than 50. More than pivot right side. Right, like this. If you take 50 as the pivot element, right, at the end of the partition 50 will go to correct place. Less than or equal to 50 one side. More than pivot right side. So partition algorithm will do this kind of work. Whichever element you take pivot, right, that will go to correct place, less than that one side, more than that other side. And one more. Whenever this algorithm is going on, pivot element asked every person, see every person you asked. Because of you are asking every person, time complexity of partition algorithm is order of n every case. Every one you are asking. But can you help me now? Partition also dividing, partition also dividing, right? In the merge sort also dividing. In the merge sort division, one line, mid is equal to I plus j by 2. But it is not one line, one loop is there. One loop is there. Partition algorithm is over, this kind of here. Can you help me one small line now? Partition algorithm is over, it return 4. What is the meaning? Partition algorithm is over, it return 4 means pivot element went to the correct place 4. See this. Partition algorithm is over, it return 4, indication that pivot element went to the correct place, right? Correct place, that correct place is 4. Pivot element is there in the 4th place. Less than 4th place one side, more than 4th place other side. Can you help me one small line now? Right? See this one. What is the meaning of pivot element went to the correct place? What is the meaning? Pivot element went to the correct place means less than that one side, more than that other side, which is nothing but pivot element went to the 4th place means 4th place is the correct place of that one, which is nothing but, right? Pivot element is the 4th smallest element. After partition algorithm is over, pivot element went to the correct place. Can you see what the correct place of this one? Fourth place. What is the meaning? Pivot element is the fourth smallest element. Indication that less than fourth smallest element is the left side. What are those? First smallest element, second smallest element, third smallest element. Afterwards, pivot fourth smallest element. Afterward, more than that one smallest element will be on the right side. One last question I want to ask you. Partition algorithm is over. Who will go to correct place? Pivot element. What is the meaning of going to correct place? Less than that one side, left side, more than that right side. What is the meaning? After partition algorithm is over, pivot element went to the fifth place means, right? Pivot element is going to be fifth smallest element. Means less than that 4 people left side, more than that remaining people. Right? Please be careful. I am thinking almost you are okay with the partition algorithm. To get the more clarity, let's take one more example. If you get a partition algorithm, quicksort is over. Please be careful. If you get a merge, listen, if you get the merge algorithm, merge sort you know. If you get the partition algorithm, you know quicksort. Just I think please be careful there in the case of the merge sort, right? Merge algorithm, one while loop, here one for loop. Just to do one or two examples practice you do, mostly you are comfortable. Comparing this one, next problem is going to be right, much easier. Still if you have doubt, one more example I will do. Right, let's start example 2. Example 2. Array A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some elements, I think I took 10 elements. Next one. 45, 80, 39, 29, 60, right? 29, 16, 19, 88, 99, 15, 23. Some numbers. Next one. Can you help me on this particular array? Apply. On this particular array, apply merge. Apply. On this particular input, apply partition algorithm. Let's start. Apply partition. Apply partition. So I am starting. First step, select one element as a pivot. Can you see which is the pivot? First element. X is equal to A of 1. Right? First element position is P. Last element position is Q. That is fine. And first element you selected as a pivot. That is also okay. Next one, P itself is I. Next one, P plus 1 is J. These are the things which you have to mark first. If someone asks you apply partition, fix these. P is first position, Q is the last position, I is first position, J is second position, X is equal to pivot element, first element, right? Everything fine. Can you help me now? I and J, which is right side? J. I and J, which is right side? J. What J want? Right side people want greater. What the left side people want? Smaller or equal? That's fine. And one more. He want greater, he want smaller. Both can move, but the compromise between them, I saying to J, right? I don't move. I is saying to the J, I don't move. J, you only move. But wherever you got greater, you take. Wherever smaller, you give to me. Right? Like that is the compromise. Start now. Who is moving? J. Right? For loop, if you see the for loop, J value 2 onwards, right? Movements will start. Let's start now. J is asking. Right? Are you greater than pivot? Yes. I think X is 45. True. Then J is equal to J plus 1. Are you greater than pivot? No. Then what will happen? J got smaller. J will inform to I am looking for greater but I got smaller. You take smaller but you give greater to me, then we can swap. I saying that I don't have the greater. Right? So I plus 1 having greater. He will increment, then he will swap. See this. So 39 here, 80 here. In the similar way, those people who are having small disturbance also after swapping is over, again same. What is the answer? J plus plus. J will always increment. J is asking, are you greater? No. Then I is equal to I plus 1, swap it. 29 here, 80 here. Same way, again J will go. Are you greater? No. I is equal to I plus 1, swap it. 16, 80. Next one. Are you greater? No. I is equal to I plus 1, swap. 19 here, 80 here. Next one, J will go here. Are you greater? Yes. Are you greater? Yes. Are you greater? No. I is equal to I plus 1, swap. 15 is here, 80 here. Next one, J is here. Are you greater? No. I is equal to I plus 1, swap. 23 here, it is 88 here. Next one, j is equal to j plus. When j crosses boundary, stop it. Indication that for loop is over. When you say j crosses boundary, what is the meaning? All elements is covered. Indication that for loop is over. After for loop is over, array will be divided into one part or two part or three part. Three part. First one, pivot. Second one, right? See this one. Second one. See every time I is incremented one time. Small came, small are equal. Right? This also small are equal. Right? Until here. So this is going to be small are equal. Wherever last I there, until that place small there. Small are equal there. Next one, remaining is greater. Right. Can you help me? After for loop, this is the story. Can you help me now? After for loop, pivot smaller greater there. But you want the pivot in the first place or middle place? Middle place. If you want pivot in the middle place, very simple. Right. Where is the last I? It is the last small. Right. See this one. These all are small. Right. In all the small people, it is the last person came. It is the last small. It is the last small. Small. What will you do? Pivot element saying that I want to come to middle. These all are small people. It is the last place where the small, see one, everyone is small, it is the last small came. Then what the after for loop is over, what will you do? Just swap a of p, a of I, because pivot should go to middle. This is the boundary, see. Afterwards greater will start. After I plus 1 onwards greater will start. So I is the place where small there, afterwards greater is there. So what the pivot saying that I will come to ith place so that after me greater, before me smaller. So same. Return, what is the answer? Swap a of p, a of I. What is the a of p? 45. What is the a of I? 23. Swap it. It is going to be 45, it is going to be 23. So not only, I think now pivot element went to the correct place. Not only keeping correct place, what is the position? I. What is the I value? 7. It will finally return 7. Now let's write the output. Let's write the output now. 7 is equal to, right, all of them 23, 39, 29, 16, 19, 15, 45. Next one 99. Next one 80. Next one 88. Position 7, 8, 9, 10. Right, now see, I think all the elements I copied as it is. Next one, can you help me once more? What is the seventh means? What is the meaning of 7? What is the meaning of 7? What is the meaning? Pivot element is there in the 7th place after partition is over. Let's go to the 7th place. Pivot element is this one. Pivot element is 45. Pivot element went to the correct place, less than or equal to pivot left side, more than pivot right side. So can you help me? After partition algorithm is over, everyone will go to correct place or pivot only will go to correct place? Pivot only will go to correct place. Pivot only will go to correct place. Not only going correct place, he kept other people also little bit okay. Not exactly, little bit okay. They came very close. Because you are doing meaningful one you done. Right? So pivot went to the correct place. Other people, he didn't kept exactly correct place, almost correct place they kept. What is the reason? Less than that is left side, more than that is right side. Almost he done the nice division. He done the division in the nice way he done. So partition algorithm not only keeping the pivot element in its correct place, it will return the position where it kept also. 7th place it kept. It means, right? Pivot element at the end of the partition algorithm went to the 7th place means, right? So pivot element is correct place is 7th place. Indication that less than that 6 people there. Remaining or more, it is the 7th smallest element. Please be careful. After partition algorithm, pivot element went to the 7th place means, right? Its correct place is 7th place, meaning less than that 6 people left side, more than that this one. This means it is the 7th smallest element, right? Please be careful. I am thinking you are almost okay. Can you help me now? One small question I want to ask you. Please listen. On this array, everyone listen. On this array, if you apply partition algorithm, on this array means how many elements are there? N elements. On this array which contain n elements, if you apply partition algorithm, time complexity order of n. One scan required. On this array, if you apply partition algorithm on n elements, time complexity is order of n. So see this one. Partition algorithm is completed. So n time is over. Then array will be divided like this. Partition algorithm is over means n time over, because one loop is over. Then result is going to be, it divides the given array into two parts like this. And some people are asking, see the one more interesting line. See the one more interesting line. On this array, careful listen, on this array, if you apply partition algorithm which will take n time, it divides the given array into two parts, it's okay. But see the one more interesting line. See this one. Before this particular array, see this one. This algorithm is called, everyone listen, quicksort on array A which contain, careful listen, quicksort on array A which contain 1 to 10 elements. It is the P, it is the Q, that's okay. Quicksort on array A which contain 1 to 10 elements. Some people are asking, what is the quicksort algorithm? This is the algorithm, see. Quicksort algorithm on array A which contain 1 to 10 is equal to, see this one, is equal to, right? First to apply partition. On that array, whatever quicksort algorithm you are given, on that array, quicksort algorithm applying is nothing but first apply partition. You will get, after partition is over, n time over, then you got this. Then what is the next step? Now apply quicksort in this area, apply quicksort in that area. See this one, quicksort on array A which contain 1 to 6. First apply quicksort on the left half, next, right, apply quicksort on the right half also, array A which contain 8 to 10. Right, see this one, and let me minimize diagram here, let me minimize, see this one, minimize the diagram, see, this is the answer. Quicksort, see everyone now, quicksort on big array is equal to, first apply partition, then division is done, then both the subproblems apply quicksort, left also apply quicksort, right also apply quicksort. Some people are asking, sir, supposition that left I applied the quicksort recursion, it will assume that it is sorted, assume that left I applied the recursion, assume that it is sorted. Can you sort this? What is the answer? If you sort this one, assume that recursion will do that. 15, 16, next 19, next 23, 29, 39. So when you say left function call completed, left one is sorted. Next one, anyhow pivot element already sorted, it is there in the correct place. Next one, let me sort right also, quicksort on the right side, recursion will be done, assume that right also sorted. So what is the answer? What is the first minimum? 80, 88, 99. So right also sorted. See this one, after partition algorithm is over, array will be divided into two parts. On both the parts, left also apply recursion, right also apply recursion. When you say left over, left one sorted. When you say right over, right one sorted. But when you say partition is over, pivot element sorted. Partition over means pivot sorted. Left over means left one sorted. Right over means right one sorted. If you want, you can check, array already sorted. Left over means left one sorted. Partition over means pivot is sorted. Right over means right is sorted, right? If you want, you can check array already sorted. If array already sorted, why should I go for combine, right? Meaningful division, this is the advantage. Meaningful division you done. Some people came left, some people came right. Left people solve, right people solve, then problem over. That is the meaning of meaningful division, right? Left people sort, right people sort, meaningful division already done. Left people don't go right, because of that is the meaning of meaningful division. Right people don't go left people don't go right, because already meaningfully done, right? So there is no need to combine further. Can you say what is the meaning of divide and conquer? Solving bigger problem in terms of smaller problem, right? So afterwards no combine also required. Using conquer, solve the left one, using conquer, solve the right one. First to divide, two parts came, further no combine required. So partition algorithm, it is the second example, right? Let's do right, one more problem. Let's do partition algorithm, one more problem, right? You will get the more clarity. See the example 3 also. Small doubt also there, please you take care. One more example. See everyone. Array A 1, 2, 3, 4, 5, 6, 7, 8, some 8 elements. Let me give the values also. 80, 55, 35, 95, 95, 85, 23, 44, 86. Some numbers required I given. Next one. Can you help me if I ask you? apply. See, so don't bother anything about, you know the total procedure you know. Apply on this one, partition algorithm. Can you say first step? P, first position. Q, last position. I, P only. J, P plus 1. Until now, fine. And one more. Who is the pivot element? First element people will take pivot. What is that one? 80. It is the current status. P, Q, I, J, everything ready. Now start now. Can you help me? What is the compromise between I and J? I saying that I want smaller. J saying that I want greater. And I saying to the J, you only go. Wherever you got greater, you take. Wherever smaller or equal, give to me. Right? Let's start. J is starting now. J will visit every person. Right? J don't stop at anywhere. Right? J will visit every person. Right? Let's start. J is asking the first person. Right? J is asking first person. I want greater. Are you greater? J is asking first person. Right? So I think, sorry, J is asking this one. According to J, it is the first person because he is starting from here. J is asking this one. Are you greater? Because J want greater. Are you greater? He said no. When he say no, J will inform to I. What he will say? J will inform to I saying that, hello I got smaller. I want to give smaller to you. But in return, you give greater to me. Then what I will say is, right? What they simply I will say the, I don't have the greater, but I plus 1 having, simply he will swap it. Same algorithm. If anyone having small doubt also, same thing only, right? Same thing. I think where, if you want, you can see our algorithm. Just follow, that is the reason I written the algorithm. That is the reason. See this one. That is the reason. J will start from 2. J will start from 2, right? See this one. A of J less than or equal to X. A of J less than, starting itself came, yes, true. What is the A of J as of now to us? Right? I think 55, 53, something like that. That is less than 80 or not? Yes, immediately. Just increment I is equal. Just follow algorithm. Right? Nothing there. If you have small doubt also there, please see algorithm. Start now again. So this one, see everyone. J is saying that, are you greater? No. Then immediately J will inform to I. Right? You take smaller and give greater to me. I will say that wherever I am, I don't have. I is equal to I plus 1 having. They will increment. They will swap it. See, they will swap. Right? Worst case, what happened? They will swap themselves. Don't worry. Simple algorithm you have to follow. I is equal to I plus 1, swap it. Right? As usual, J will go next. J is asking, are you greater? No. Then I is equal to I plus 1, swap it. He is swapping himself. There is no problem at all. Just follow algorithm. Next one. Are you greater? Yes. Are you greater? Yes. Are you greater? No. Then I is equal to I plus 1, swap it. 2395. Next one. Are you greater? No. Then I is equal to I plus 1, swap. 4485. Next one. Are you greater? Yes. Right? So J is equal to J plus 1. Crossing happened. Whenever crossing happened, stop. Array will be divided into how many parts? Array will be divided into how many parts? 3 parts. First, pivot or pivot. Next one, small or equal. Until last I think until here. Afterwards, greater. Right now, let's see this one. Right, greater. Can you help me? This is the end of the for loop, not end of the algorithm. End of the for loop. End of the for loop. This is. But pivot element is there in the first place. You want first place or middle place? Middle. So can you help me? Middle place. What is the answer? See, these are small people. Afterwards, big. After which place big? See, this is the last. Right. This is the last small. So afterwards, big there. So this place pivot will come. Pivot place he will go. It will become now 80. It will become now 44. Now, not only that, not only keeping pivot in the correct place, which place he kept? 5th place. So 5 is here. So let me write the answer, whatever we got until now. After partition on n elements, it will take n time. That is everyone now, because one loop required. Let's see the output. What is the answer? 5 is equal to. Right? Say all the things I will write. 5 is equal to. What is the answer? First, 44, next 55, next 35, next 23, next 80, next 95, next 85, next 86. 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements, 8k. Right? Next one more thing. Right? One more thing. Can you help me? Which place pivot element went? 5th place. It is a pivot. Less than pivot one side, more than pivot other side. So apply quicksort on the left also. Apply quicksort on the right also. Can you help me one small enough? Before applying conquer, who sorted already? Pivot already sorted. because he went to correct place. So left people may not be correct, right people may not. See, they left people don't go to right people don't go to left, but one thing within left, see, there may be change of order, there may be chance that here also change will happen. That is the meaning. Left one sort using recursion, right one sort using recursion, right? If you sort, what is the answer? Left one sort, first 23 will come, next 35 will come, next 44 will come, next 55 will come. So this 80 is as it is. Next one, this also sort, 85 will come, next 86 will come, next 95. Right? Total array is sorted. Totally 8 elements, total array is sorted. So one more thing, let me say this. Quick sort on array which contain 8 elements if you want to sort. Right? First apply partition, n time is over. Left, what is the answer? Quick sort on 4 elements called recursion. Right? Quick sort on 3 elements called recursion. One is pivot, already sorted. To sort this one, n time required. Not only that, it done some other work also. Afterwards, recursion will take care remaining story. So this is the partition algorithm. Now, whatever you understood, it's okay. Can you help in a partition algorithm purpose? Dividing the given array into right, two parts. Right? Blind or meaningful? Meaningful division. Because of meaningful, everyone will participate. So n time. N time is best case or worst case? Every case. Right? What is the meaning of divide and conquer? Solving bigger one in terms of smaller one. In the quick sort, is there any combine? No. Why? After conquer step, total problem solved. What is the requirement of combining? So I am thinking that you are absolutely fine. Can you help me in the quick sort major person? Partition. Partition you are okay means you are okay with the quick sort also. Now because the partition is over, let's go to the quick sort. Partition algorithm you are comfortable. Let's see the quick sort algorithm. See everyone now. Quick sort algorithm. Right, so I am writing this. See everyone, quick sort on array A, quick sort on array A which contain P2Q elements is equal to, what is the answer? One element, there is no need to divide and all, right? If P is equal to Q, one element, return A of P, only one, that itself is answer, it's okay. Come to the major part, else. Problem is a big problem. Then what is the answer? If P is equal to Q, return A of P, means small problem this story. See the big problem. If the big problem, in the merge sort, what you done? Directly blind division. But what you will do here, see this one, right? Just to do partition. Partition algorithm on array A which contain P2Q. Right? So when you say partition algorithm is completed, what is the answer? It will return, right? Not only keeping the pivot elements in its correct place, it will return the position where it kept. Assume that it kept in the m, right? Mth place it kept. It's something like this. See this one. It is something like this one. Array A which contain P2Q elements, after partition algorithm is over, pivot element will go to somewhere, right? Its position is m, right? It will return m. You know very well. So what is the meaning? Right, pivot element is there in the mth place, right? Less than that is left side, more than that is right side. If you are okay, can you help me now? Where is the pivot element now? Mth place. Who are the left people? Less than mth. Who are the right people? More than that. Can you help me one smaller? What is the answer? Where is the left one? Apply quick sort on array A which contain P2 m minus 1. P2 m minus 1. Okay, once again, apply quick sort on array A which contain, what is the answer? M plus 1 to Q. Right, like that apply. Lastly, I think after this one, after completion of this line, what is the meaning? Pivot sorted. After completion of this one, left sorted. After completion of this one, right sorted. Means array sorted. Return. Right, return. Right, array A. Right, end of this. Right, end of this. This is the part, this is the quick sort algorithm. First, just only new thing is partition. Remaining all are normal. Because of it is a meaningful one. There is no combine. See, after conquer is over, no combine, nothing. Because of partition, E completed. Because of left one, E completed. Because of right one, E completed. Means total array sorted. Return. Right? Fine. So this is the quicksort algorithm. I forgotten to say one small line. Please listen this one. Right? Please listen this. See this one. See this algorithm. Partition algorithm. I forgotten to say this line. Right? See this one. If you see the partition algorithm, see correctly. What is the array name? A. See this one. Array name is A. If you see inside, nowhere array name B. See this. Right? In the partition algorithm, if you observe, A is the input. See this one. A is the array which is the input. Right? But nowhere B there. Nowhere B. What is the meaning? It is an in place algorithm. Nowhere B there. But when you see the merge algorithm, right? A and B both you are using. But here A only, right? But nowhere B there. So it is in place algorithm. If you want, you can check. See the examples also. See, within the array only all swappings are going on. Right? Same output, same thing only, because of so many cancellations here. Same thing only I copied here. Right? And one more example. See this one. Same array only all swappings are going on. Right? Finally output is this one. Just I stored the same thing here. Right? If you want, you can see, I think one more example may be there. Right? Right, that's fine. So these are the things. See the third example. See the one more example. Here also all are going on within that array only. So it is the in place algorithm. I want to say that it is the in place algorithm. Right? Please be careful. Right, come here. And one more. If you want, you can check inside quicksort also. Nowhere, see, A array, nowhere B there. So it is in place. Let me write here itself. It is in place. It is in place algorithm. Quicksort is in place. There is no requirement of extra space more than log n. Right? So it is the algorithm. This is the only extra. Right? Now let me analyze also. Quicksort algorithm on an element time complexity Tn, if you are okay, right? Can you say what is the small problem time? Constant, that is okay. Next one, if big problem, partition, n elements, n time, that is also fine. Next one, what about left, what is the right? Please check. Can you help me? Partition algorithm will divide the given array or not? Partition algorithm will divide the given array. See this one, two parts. Partition algorithm will divide the given array into two parts. Please be careful. Right? It divided. So n time for the partition, afterward division is there. Afterward division. Please be careful. Right? Next. And one more thing. Partition algorithm will divide the given array into two parts with respect to pivot element. With respect to pivot element. Please be careful. With respect. Partition algorithm divided the given array into two parts with respect to pivot element. Please be careful. Right? I am thinking that you are absolutely fine. So I think everything is ready. So now I am starting. Tn is equal, carefully listen this also, Tn is equal to time complexity of time of quicksort of n. Tn is equal to time of quicksort of n. Right? It's okay. See this one. Right? Otherwise I will recurrence relation for time I am writing. Fine. What is the meaning of Tn also I define. Now let me write. Tn is equal to, can help in a small problem how much time? Constant. If n is equal to 1, that is fine. That is the if case. Come to the else case. Can you see in the else case? In the else case, what is the first one? Partition. How much time? N plus else part. Right? Partition. N plus next one. Two recursive calls are there. Two recursive calls. This one and this one. Can you help in here how many? It divided the given array into two parts, fine, right? But one thing, with respect to pivot, please be careful. Can you help me now? Left how many people, right how many people? You say, I will write. Partition algorithm will divide the given array into two parts, I am okay. With respect to pivot, that is also okay, right? Can you help me now? Right? What is the size of left, what is the size of right? Please careful. Can you help me now? What is the first element position? P. What is the last element position? M minus 1. Can you help in a total elements how many? Total elements how many? Right? M minus 1 minus P plus 1. Cancel. What is the answer? M minus P. So T of M minus P. Right? These many left too. Right? Next one, what about right? Same way. What is the answer? Q minus plus 1. Plus 1 minus 1 cancel. Q of T Q of M. This is right. This is right. And one more thing I want to ask you. Please listen. Some students are misunderstanding. That is the reason I am saying. Partition algorithm is over. It divides the given array into two parts. It's okay. But it will divide blindly or meaningfully. Meaningfully. When you say blindly, 50-50. I am okay. Left half, right half. I am okay. But here not left half, right half. Depending upon pivot element. Right? Left how many will come, right how many will come. It need not come exactly half. Sometimes what happened is one side no one may be there. Because depending upon pivot, you are not doing blindly, you are not doing blind division, you are dividing meaningfully. Can you help me now? After partition algorithm is over, where pivot will go? Correct place. Less than pivot one side, more than pivot other side. Supposition that in the given array, right? Less than pivot no one there, left gap will come. More than pivot no one there, right gap will come. Suppose that less than pivot, more than pivot, half is there. There may be chance of 50-50 also. Those people, listen, some people are thinking that partition algorithm is n time, left is Tn by 2, right is Tn by 2. If anyone thinking like that, right, that is also right, but need not be every case. That is the reason I took some time. You may be thinking that it is the Tn by 2, it is the Tn by 2. Here n by 2 elements not there, because if you do blind division like merge sort, left 50, right 50. But it is not left 50, right 50. Left, depending upon pivot, some people will come. Left maybe sometimes no one will come. Left maybe sometimes 1 will come. Left maybe sometimes 5 only will come. Left maybe sometimes 50-50 will come, something like that. Anything can happen. So actual way of writing M minus P. Right? M minus 1 minus P plus 1, just to do calculation. This may be 0 also sometime. This may be n by 2 sometime. This may be n minus 1 also, because right no one, all may be left. With respect to pivot, right, partition will be done. If the pivot element is smallest element, assume that pivot element is smallest element, less than him no one, all will write only. If the pivot element is the greatest element, assume. Right, more than him no one, all are left only. If the pivot element is the middle one, assume that, then 50-50 will come. Any combination can come. Right, if anyone thinking 50-50, Tn by 2, that is also right, but need not be every time. Need not be every time. Please be careful. Right, that is the reason I took some time, so that what you are thinking, right, so is it right or wrong, you can verify. This is the only difference. Can you help me now? Right? Quicksort division, merge sort division. Which is the fixed division? Quicksort division, merge sort division. Which is the fixed division? Fixed means always same. Merge sort. Why? 50-50. But it is not always same. It will divide with respect to pivot. It is not fixed division. It is a variable division. Division is keep on changing, depending upon which element you will give pivot, division will change. If you want, we have 3 examples also. We done already 3 examples, you can see that. On the board they are available. Let me check here. If you want, you can check. See this one. In this array, how many elements are there? 8 elements. 8 elements. Right? If at all 8 elements are there after partition is over, please check. Right? See this one. Left 4 came, right? Right is going to be 3 only came. This is the one example, right? So this is the example number, whatever it is, this is one example. Let's see the one more example. See this. See this also. See this. Total elements are 10. See this one. Total elements are 10. Left 6 people came. Right only 3 came. Total elements are 10. Left 6 people came. Right only 3 came. Right. This is the, I think, first example. This is the first example, right? I think this is the second example, right? So come to the first example. It is the first one. See the first one? See the first one here. So total elements are 9. Total elements are 9. Left only 3 came. Right? Right is going to be 5 came. Right? So right is 5 came. Right? Left 3. Right? I think plus 1. I think 5 plus 4, 9. Total 9. Left only 3 came. So in the example 1, I am repeating once again. In the example 1, 9 elements are there. Left 3 came. Right 5 came. In the example 2, if you observe, total elements are 10. Out of those 10, left 6 came, right only 3 came. That is example 2. Example 3, if you observe, this is example 3, right? Total elements are 8 there, left 4 came, right 3. This may be 50-50 combination. Right, those may not be 50-50. So what I want to say, after quicksort, listen, quicksort algorithm partition is completed, division is done. How it is done? With respect to pivot. Because of you are little bit lucky here, because of little bit you are lucky here, left and right something came, right? Sometimes left no one may came. It depending upon completely which is the pivot element you are taken. If the pivot element is a nice one, 50-50 will come. If the pivot element is a nonsense, left no one may come, all may be right, right? Something like that, right? Please be careful. I am going back to our actual story. Write this one. So partition algorithm n time, right? Depending upon a partition algorithm, division will be done, right? If you are lucky, right, it is also n by 2, it is also n by 2. If you are unlucky, it may be 0, it may be n minus 1. It may be n minus 1, it may be 0, right? Sometimes maybe year 2, year remaining, year 10, any combination can happen. Problem to problem, it is keep on changing. Can you help in last time I want to ask you, merge sort, quick sort, who will divide? Both. Who will divide? Fixed division, merge sort. Because of it is a fixed division, careful listen, merge sort is a fixed division every time, by 2, by 2, by 2, by 2, n log n, n log n. Because of it is a variable division, different time complexities will come. From today onwards, if anyone asks you, why quicksort will give different time complexities, what will you say? Partition algorithm is keep on dividing differently. Every time it is not dividing in the similar way, it is dividing every time differently, that is in different time complexity. If you at all you are lucky, it may be do balanced division. Suppose can you help it is behaving whenever partition algorithm is running, it is dividing the given array like merge sort, then what will happen? 50-50. So if at all 50-50, it is a Tn by 2, it is a Tn by 2, 2Tn by 2 plus n, exact like merge sort reconciliation, n log n you will get. If you are lucky, balanced partition will come. If you are unlucky, what is the meaning? Unbalanced will come. What is the meaning of unbalanced one? One side no one, all are other side only. Then that may be worst case. Once again I am asking you, quicksort, merge sort, which is the variable divisions? Quicksort. Because of variable divisions, what problems are coming? Right? Different time complexities will come. Because of fixed division, what is the advantage? Every time same time complexity. How much? N log n. Because always by 2, by 2, by 2, by 2 like that. Anyhow, it is a generalized one, right? How many there? Those many, right? Don't write more, don't write less. What is the answer? M minus 1 minus P plus 1. Q minus M plus 1 plus 1, right? This is, now let me write now. Time complexity of quicksort is equal to partition N plus. Left how many? T of M minus P. Right how many? If anyone having small doubt also, sir, what is this N? If you want, you can write this N also. What is this N? I am writing. Right, n is equal to, this may be the case, right, this one, this n, right, n is equal to this is the thing what I want to, q minus p plus 1, if you want you can write, same thing, right, this n is going to be q minus p plus 1, fine. So, time complexity of the quicksort Tn, where n is this one, is equal to n plus T of m minus p plus T of q minus m, if n is greater than 1, right, please be careful. Nice discussion is happened until now, please take care. This is the reconciliation for quicksort time complexity. Right, now come to the next one. Let me define further. Right, see everyone. So I'm going further. Please see, time complexity of the quicksort Tn is equal to this one. Right. So can you help time complexity of the quicksort Tn will goes to this one. Can you say is it best case? Is it worst case or average case? Every case, because I am not written any best and worst. As it is I written. As it is I written. This is the time complexity of quicksort every case. Please see. Reconciliation for time complexity. Nowhere I written best case. Nowhere I written worst case. It is the time complexity of quicksort generalized reconciliation. Not more, not less. Right? Please be careful. Time complexity of the quicksort Tn is equal to apply partition n. Right? So next one, it can be any kind of division, right? M minus P plus T of Q minus M, right? Like that. This is the, because of it is covering all, it is every case. See, nowhere I written best case, worst case. It is a generalized one. Simply, if anyone asks you from today onwards, quicksort algorithm, time complexity, reconciliation, this one. Major one, see if anyone little bit disturbed also, major one, this only. Because of it is behaving differently, here different things will come. Right, I hope everything is fine now. Right, let's start this. Right, this one, let me go little bit deep about this. See this one, quicksort time complexity Tn is equal to n plus this one, it's okay. Now see what happened. See everyone now. If you are lucky, what can happen? Assume that, right, you are little bit lucky. What can happen? This is the case. See, this is the case. Time complexity of the quicksort Tn is equal to, if you are little bit lucky, first partition n over, right? After partition n over, balanced partition may happen. What is the answer? Left half, right half may happen. This may happen if you are lucky. Which will goes to what is the answer? 2Tn by 2 plus n. Which will goes to 2Tn by 2 plus n. If we solve this one, using, right, master theorem, substitution method, whatever, if you do substitution method, log n times, if you do, it will become theta of n log n. This is the best case time complexity of quicksort, right? Please be careful. Next one, come to the next one, right? Same recurrence relation. So same recurrence relation. What are the meaning of this one? Can you help me now? This will goes to, see this one. Yeah, assume that m value n by 2. After partition algorithm is over, this may be the case. After partition algorithm is over, m returns n by 2. Assume. Sometimes partition algorithm over, pivot element may go to middle. Assume that m n by 2. If you want, you can substitute. If m is n by 2, right? P is 1. n by 2 minus 1 means n by 2. Forget about minus 1 plus 1. Right? N by 2 minus 1 is going to be n by 2. Next one, what is the Q? N. N minus n by 2, which will become n by 2, like that. If you are lucky, best partition may happen like this. Suppose, interesting one. Suppose, assume that you are unlucky. Assume, right? Worst case. Right? Worst case. See this one. Worst case time complexity of quicksort Tn is equal to apply partition n plus. Apply partition n plus. Can you see? Partition algorithm is over. How many people will sort? Pivot element sort. It will go to correct place. Right? Partition algorithm is over. Pivot element will sort. Means it will go to correct place. Totally n. Partition algorithm over. One element will go to correct place. Remaining how many? N minus 1. Right? Remaining n minus 1. See what happened. Left hand side no one will go. Right hand side all will go. Left hand side no one will go. Right hand side all will go. Right? This one, if you simplify, it is called as unbalanced behavior. If you simplify this one, Tn minus 1 plus n. Right? If you solve this recurrence relation, n times it will go, because always minus 1, there is no division. Right? Always minus 1, minus 1, minus 1, like that, n time, it will go to this kind of series. It is the first recurrence relation which we solve. Right? This will goes to big O of n square. This will goes to big O of n square. N times if you do substitution method, big O of n square will come. So quicksort best case time complexity n log n, quicksort worst case time complexity n square. And one more thing, listen, one more thing. If you take so many examples, carefully listen, if you take so many examples and if you verify, right, take so many examples, right, I think I took 3 examples, you can verify those also. Take so many examples and verify, you got to know that most of the time quicksort behaving like best case only. Most of the time. It is very rare incident this kind of behavior will come. If you want, you can check our 3 examples. 3 examples I took, right? Nowhere left 0, right 0, okay. Nowhere. Most probably, right? This kind of behavior only will happen. That is the reason, right? Quicksort best case and average case same. Most of the time, this only happening. From today onwards, if anyone asks you, quicksort recurrence relation for time complexity, they are not mentioned best case or worst case, right? Quicksort algorithm, time complexity, recurrence relation. If anyone asks you, right, give this. This is actual. Don't substitute any value. Actual is this. Next one. If anyone asks you quicksort best case, okay, balanced partition, right, like this. Average also same, because some people are asking why quicksort best case, average case same. If anyone asks you, most of the samples, most of the examples they are taken, many examples they verified also. They got to know most of the time this behavior only happening. So quicksort best case, average case, recurrence relation for time, this one. If you solve n log n, you will get quicksort worst case, unbalanced behavior. Unbalanced behavior, worst case becomes n square. This is the recurrence relation. What is the recurrence relation? After partition algorithm n time over, remaining elements n minus 1 will go to one side only, see, one side only. Other side is 0. 0 means nothing there. Now see, if someone asks you from today onwards, quicksort algorithm worst case when it will come, what will you say? Partition algorithm dividing the given array, not 2 parts, 1 part only. Means all are going one side. When the quicksort algorithm will give best case, what is the answer? Partition algorithm dividing the given array into 2 parts, right? 2 parts in the best manner, balanced manner, right? That is going to be best one. See, best only happening majority times. close to best only happening, right? That there is an average also same. Most, listen everyone, quicksort algorithm, most of the time will happen this kind of behavior only. That is in best case, average case n log n, right? Worst case is going to be n square, right? It is very rare incident. It is very rare incident, but one thing, quicksort having this drawback. If anyone say, right? If anyone say they are not liking quicksort, if anyone say worst case is the reason. But one thing, that incident very rarely will happen. Mostly best and average case only happening. That is the reason quicksort is the practically used sorting algorithm. Practically used sorting algorithm. Only for namesake worst case there. It may not happen also. But one thing, worst case is there. In gate examination, someone asks you quicksort worst case, say n square. Only for gate exam purpose, this is there. Only for gate exam purpose, worst case n square. Right? Normally people will say that quicksort time complexity n log n. Right? Worst case n square for gate exam purpose, please remember. It is the best case average case reconciliation for time complexity. It is the worst case reconciliation for time complexity. This is for all cases. And one more, why different cases are coming is partition algorithm dividing every time differently. Right? If it is dividing differently, different answers will come. But in the case of merge sort, always 50-50, this only. Merge sort is every case this only. Quicksort is sometimes this kind of behavior is there. Right? Sometimes this kind of behavior is there. Fine. I'm thinking that you are really comfortable, right? But let me say one more interesting line. See this one. Let me say one more interesting line. It will confuse you, right? Listen, it will confuse you. Just I want to say one small line. Just listen this also. Best case, this is the story, right? Time complexity is going to be n log n. Worst case, this is the story. Time complexity is going to be n square. That is fine. But one thing, if you divide by 2, how many times? Log n time. So this is going to be stack space. It is a stack space. So quicksort algorithm best case stack space. How much? Right? Log n. Quicksort algorithm best case stack space is going to be log n. Next one, best case and average case. Best case and average case, quicksort algorithm, right? So stack space is going to be log n. Please be careful. Quicksort algorithm worst case stack space. Right? Best case and average case stack space log n. Worst case stack space, see this one. Worst case stack space, how much? N level tree, n level. What is the answer? Worst case stack space. Worst case stack space is going to be quicksort worst case, right? N stack space. Stack space means here extra space, right? Extra space. Let me write. Here extra space. Stack here only one thing there, right? Stack only. Extra space quicksort best case and average case is going to be log n, right? Quicksort worst case stack space or extra space, how much? Right? N. Now can I help you now? Quicksort best case and average case extra stack space is going to be log n, but worst case is going to be n because of this one. Worst case it is taking n space stack it is taking. Quicksort is not in place. Right? See, if you want you can check. Stack space itself is n. Stack space means extra space. Right? Worst case quicksort is taking, right? N stack space means extra space it is taking n, means quicksort is not in place, then quicksort becomes out place. Is it right or not? That is the reason. See this one. Because of it is taking worst case stack space is n, because of this n it is not in place, then what happened is, listen, what happened is the same algorithm they minimized using non-recursive behavior and all. Same algorithm they written in the efficient way. Instead of saying non-recursion, right, I can say efficiently. See, same quicksort algorithm if you write efficiently, right? Efficient quicksort algorithm. See this one. Efficient quicksort algorithm if you write, right? What happened is, same algorithm if you write efficiently, what will happen? See this one. Time complexity. See this one. Time complexity. Best case and average case. Same algorithm, same logic only. Same, listen everyone now. Same logic, one algorithm I written, one more algorithm they written efficiently. Same logic is same. Same logic, right? The one algorithm I written, they written one more algorithm efficiently. Then what happened is, time complexity best case and average case becomes, because of same logic, right? N log n time. Worst case becomes n square. Time complexity no change because of same logic. But they written efficient algorithm so that space will be decreased. So what happened is this one, right? Extra space. extra space. Efficient quicksort algorithm, extra space is going to be, see everyone now, best case, right? Make sure that everyone listen. Best case is going to be, right, one space. Best case is going to be one space. Worst case and average case. Worst case and average case becomes, right, order of log n. Order of log n. Right, best case is 1, worst case and average case of the quicksort stack space becomes log n. Right, efficient quicksort algorithm. If required, I could have written that algorithm also. I know that algorithm, really not necessary. That is the reason I didn't written. Can you help me? How many people will go? This algorithm. What is the best case stack space? Log n. Best case and average case stack space log n. Right? So worst case stack space n. That's okay. To this algorithm, this is the story. In GATE examination, this program is given. This answer only you have to give. Right? In GATE examination, if they ask you, if they don't give algorithm, if they ask you efficient quicksort algorithm, otherwise quicksort algorithm. This algorithm given, say this story. If they ask you simply quicksort algorithm, extra stack space if they ask you, best case 1, worst case and average case log n, just say this. I want to write that algorithm also, really not required. Suppose if anyone say it is not possible at all, if anyone say like that, sir, something like this is not possible, if anyone saying like that, right, then quicksort becomes outplace. I also thought that it is not possible at all. I also thought that n stack space required, how quicksort is in place, right? Whenever I am studying the algorithm subject initial days, right, in one of the class, one student asked me, quicksort algorithm worst case stack space is n, means extra space is n. How can you say quicksort is in place? But every book is saying that quicksort is in place algorithm. Now afterwards I got to know that same quicksort algorithm, right, the logic whatever we knows, they written efficiently because of same logic, same time complexity, no change, right? Because of efficiently they done some minimization and all. Then to that algorithm, best case 1 will come, worst case and average case becomes log n, right? Because of, see this one, maximum stack space, maximum extra space is log n or less than log n, quicksort becomes in place algorithm. But please remember this one, you remember efficient, see this one, EQS, what is the meaning? Efficient quicksort algorithm, right? Time complexities are same algorithm, only differently they written. Extra stack space is going to be this one because of this reason, right? It is in place. Please be careful. So it is going to be in place quicksort. It is not in place quicksort because worst case n required. It is not in place quicksort, that is in place quicksort. Because of logic is same time, space only will save. Right, I think whatever happened until now, let me explain. Right, so before going to end this story, let me explain now. See this one, first I explained partition algorithm, everyone clear, I am okay with that. Partition algorithm, you are okay. See this one, after partition algorithm is over, right, quicksort algorithm I written. Quicksort algorithm writing is nothing but nothing there, partition followed by 2 recursive call. Partition will divide n time, because of it is dividing with respect to pivot, different divisions. I cannot say 1, I cannot say 2, I cannot say 50-50. How many there? Those many, right? So time complexity of quicksort is equal to these 3 things add, right? Then it one, this one k, this is k. Next one. So these values, sometimes what happen is if you are lucky, best partition can happen. Sometimes worst partition can happen. If the best partition time complexity n log n, if the worst partition time complexity n square, but while solving log n stack required here, while solving n stack required here. So extra space is going to be log n for best case and average case, right? Here extra stack space is going to be n, right, for the worst case. Because of this n, then what is the answer? It is not in place. But every book is saying that quicksort is in place. Then what I done is, right, I refer some books and all. Then what they mentioned is, this algorithm is not in place because of extra stack space worst case n. So efficient quicksort algorithm, same thing if you write in the better way, right? Extra stack space becomes minimum is 1, maximum and average case is going to be log n. Right? Minimum is 1, right? Maximum, right, is going to be log n, right? Please be careful. So after writing that algorithm in this fashion, then it became in place. Because of same logic, time is same. Right? Please be careful. This is a very, very important point. From today onwards, if anyone asks you, this quicksort algorithm, please be careful. If at all algorithm is given, you have to talk this only. Algorithm not given, maybe they are talking about this algorithm. Time is same, don't worry. Right? Time is same, don't worry. Space only. If at all algorithm is given, whatever algorithm they are talking, talk that only. If different algorithm, efficient algorithm is given, this one you have to talk about space. Right? Because of it the efficient one, you have to follow this only. Efficient one, you have to follow this one only. Right? Please be careful. Efficient quicksort algorithm, right? So extra space is going to be best case one, worst case and average case is log n. In place. Time is same. Right? Please be careful. Now I am stopping, I want to ask you finally. So forget, just this is the only thing which you have to by heart maybe. I can write one more algorithm also, it is the wastage of time. That is the reason I am not writing. You can easily remember also, quicksort is in place. Easily you can remember. Okay, in place means what? It don't go more than log n. So worst case n, no chance at all. It don't go more than log n. Minimum is 1, maximum and average case is going to be log n. Right? Please remember. So if I stop here itself, definitely one of the person will send. You are saying quicksort is in place, worst case n stack space required. How it is in place? There is a one efficient algorithm which can save the space. See, binary switch also we done say. Right? Binary switch algorithm, recursion, non-recursion. Non-recursion is one only taking. Like that, you can write the efficient quicksort algorithm. Extra stack space is going to be minimum is 1. Right? Worst case and average case is log n. So in place because of that reason. So if anyone having small doubt also about the efficient quicksort algorithm, just Google it out. Really not required. Through experience I got to know. Initial batches I used to say that also, it is the wastage of time. If you want, if you are interested, just type one thing, efficient quicksort algorithm. Right? Efficient quicksort algorithm for space. You just Google it out, you will get one algorithm. Right? Fine. I think you are. Can you help me in the entire story? Major algorithm, partition. Right? I am thinking that quicksort you are absolutely fine. Right? Quicksort you are absolutely fine. We will go to the numerical problems right after this. Right? Fine.